Let's swing into the action. So the first question that pops up in your mind is, what can Kubernetes do for you, do for me, do for us? So with modern web services, users expect application to be available 24/7, and developers expect to deploy new versions of those applications several times a day. I hope you might also be expecting these kind of things. You would also want to see the versions upgraded every several times a day. So to do all those things, containerization helps package a software to serve these goals. So enabling applications to be released and updated without downtime. So Kubernetes helps you make sure those containerized applications run where and when you want, and helps them find the resources and tools they need to work. So Kubernetes is a production ready open source platform designed with Google's accumulated experience in container orchestration combined with best of breed ideas from this community. So let's look into the production level Kubernetes flow. Production ready Kubernetes flow. So it begins with creating a Kubernetes cluster. So Kubernetes coordinates a highly available cluster of computers or instances or virtual machines that are connected to work as a single unit. The abstractions in Kubernetes allow you to deploy containerized applications to a cluster without tying them specifically to individual machines. To make use of this new model of deployment, applications need to be packaged in a way that decouples them from individual hosts. They need to be containerized. So containerized applications are more flexible and available than in past deployment models where the applications were installed directly onto specific machines as package deeply integrated into the host. Kubernetes automate Kubernetes automates the distribution and scheduling of application containers across a cluster in a more efficient and effective way. So Kubernetes is an open source platform and is a production ready. So then the second step in the production ready flow is to deploy an app into our cluster. So once you have a running Kubernetes cluster, you can deploy your containerized application on top of it, inside the cluster. So to do so, you create a Kubernetes deployment configuration or Kubernetes deployment object or a Kubernetes deployment resource, whatever the way you call it, but the purpose is to deploy it. So the deployment instructs Kubernetes how to create and update instances of your application. Once you have created a deployment, the Kubernetes control plan schedules the application instances included in the deployment to run on individual nodes in the cluster. Then the third step is explore your app. So when you created a deployment in step 2, Kubernetes might have created a pod to host your application instance. A pod is a Kubernetes abstraction that represents a group of one or more application containers such as a Docker and some shared resources of those containers. Those resources include shared storage as volumes, networking as a unique cluster IP address, information about how to run each container such as the container image version or specific ports to use. Then the fourth step is expose your app publicly. So Kubernetes pods are mortal. So pods have a life cycle. When a worker node dies, the pods running on the node are also lost. So that's the reason a replica set might then dynamically drive the cluster back to the desired state via the creation of new pods to keep your application running. As another example, consider an image processing backend with 3 replicas. How many? 3 replicas. Those replicas are exchangeable. The front-end system should not care about backend replica or even if a pod is lost and recreated. So that said, each pod in a Kubernetes cluster has a unique IP address. Even pods on the same node will have a unique IP address. So there needs to be a way of automatically reconciling changes among pods so that your applications continue to function. A service in Kubernetes is an abstraction service, a service object. A service object in Kubernetes is an abstraction which defines a logical set of pods and basically applies a logical set of pods and a policy by which to access them. So services enables a loose coupling between dependent pods. A service is defined using YAML, YAML script or JSON, that is JSON, like all Kubernetes objects. The set of pods targeted by a service is usually determined by label selector. So then scaling an application. So in the previous step that we have discussed, that's expose your app publicly. That time we have discussed about the replica and then we also discussed about the service. So we in previous steps we have created a deployment and then exposed it publicly via a service. If you want to expose the app that you have created into the Kubernetes cluster in the step 2, if you want to expose it to the external world, the option for you in Kubernetes is using the service object. So the deployment created only one pod for running our application. When traffic increases, we'll need to scale the application to keep up with user demand. So that's why we will go with the scale up of our app. Then the final one, this is what we do for the scaling up. And final one, the sixth step is to update our app. So users expect applications to be available all the time, and developers are expected to deploy new versions of them several times a day. In Kubernetes, this is done with rolling updates. Rolling updates allow deployments update to take place with zero downtime by incrementally updating pods instances with new ones. The new pods will be scheduled on nodes with available resources. In previous module, we scaled our application to run multiple instances. That's in step 5. So this is a requirement for performing updates without affecting application availability. By default, the maximum number of pods that can be unavailable during the update and the maximum number of new pods that can be created is 1. Both options can be configured to either number or percentages. So in Kubernetes, updates are versioned and any deployment update can be reverted to a previous stable version using rollout. Now it's time to deploy and run and access our first application, that is Hello Docker Desktop, and that we are going to do in a single node cluster. So I'll take a sticky note. So this is our first exercise in Docker in K8 in action. So this is exercise 1. And it is Hello Docker Desktop using Kubernetes. So this tutorial demonstrates how to run a sample app on Kubernetes using Docker Desktop and Kubernetes. So it will create a single, so using Kubernetes extension in Docker Desktop. So here we are gonna create the first step is create a single node cluster. That's a single node K8 cluster, a Kubernetes cluster. Then 2, once it is done, 2, we will write our deployment file. We have to create a deployment. So create a deployment. Then once the deployment has been created, then we will create a service, because without service it's impossible to expose this to the external world. So here when you create a deployment, the pod will be created and replica sets also can be created. And then 4th, access this app, access this through internet. And then 5th, clean up. So these are the things or tasks we are gonna do, nothing much. So let's get into the action. So before that, I would like to show you some important aspects. So this is what it consists of. So the first step is to create a single node. If you want to create a single node, you have to get into the Docker Desktop. So this is the Docker Desktops. The prerequisite is Docker desktop should be installed in your computer. So I hope everybody has Docker desktop in their computers. So now let me click on settings icon, and here you should see different settings on vertical menu bar. So I'll click on Kubernetes, the fourth one of left vertical menu bar. Yeah, here. So Kubernetes V version 1.25.4, this extension we have. So I'm gonna say enable Kubernetes. So start when you say enable Kubernetes, what it's gonna do, it will start a Kubernetes single node cluster. You see that? It will start Kubernetes single node cluster when starting the Docker desktop. So, but how will it start? Of course, see, when we click here and then say apply and restart, it will start. But how will it start? The question should come in your brain. I'll show you. So let me randomly open git bash. Okay, and pull it here. Yeah. So what I'm gonna do is I'll say cat and tilde and kube and config. See that? This is the present kube config file that we have. So let me clear the screen and execute the same. And here is the kube config file. So let me explain it one more time, because without kube config file, the kubectl cannot be used. Kubectl cannot access the cluster. So that's the reason I'm saying. So now we have we have a default config file after the when you install a Docker desktop, this config file will also be installed in your directories. So this consists of API v1 cluster. This is the cluster information. So the cluster till here, yeah, the cluster is https kubernetes docker.com. Okay, this is part of Docker desktop. So the space, the server, the cluster space, you will get it in the Docker desktop directories. Okay, and the name of the cluster is Docker desktop. You see that? Docker desktop. We are going to get into that later. Okay, the context here you see. So what it's going to do is it's going to marry, or it's going to connect the user with the cluster. So cluster is Docker desktop. It's a part of Docker desktop directory, whereas user is me. That's kubecharan. Okay, this is me. So now this context is attaching user with the cluster. So this is properly done. You don't need to do anything else. So, and one more context in this, it's a, here you should see cluster name and user and the name. So current context is Docker desktop again, no problem at all. Now let's look into the users. So users, we have only one user, that is Docker desktop. So Docker desktop is going to use this. So, and this is the client certificate data, and this is the client key data. So I hope you got it. So we have this. So that's the reason we will able to access, we will able to use kubectl. So let me write the prerequisites and then let's get into the action. So prereqs, one is Docker desktop, 2 is kubectl. Rest all would be fine. You don't need to touch anything. In Windows machine, it's specific to Windows machine. Of course, you can do the same with other machines also. But these are prerequisites, and this is are the steps that we are going to do. Okay, so we have the config file. So obviously we can use kubectl. We can connect with our cluster also. But where is my cluster? So the cluster I am going to create. So I'll say apply and restart. Just now we have seen so config file, as you have a config file, So now it can start the cluster. So let's wait for some time until it starts the cluster. So by the time, what we can do is we will clear the screen and we'll say kubectl, yeah, and help. And these are the some of the commands of kubectl. So out of whichever command that we widely use, that I'm gonna say create, we use widely to create a resource. Basically any resource, any object, we'll use a create directly. And similarly we use apply also for the same. Here is that advanced commands, these are advanced. Create is the old one. Apply, it applies a configuration to a resource by file name or std in. So patch and diff and customize, and we have create, expose, run, and logs. You see that logs exec and describe, it show details of a specific resource, group of resources. So it's taking more time, but you could see that Kubernetes is starting. And tooltip, when you hover over to this icon, Kubernetes icon, so it is the tooltip is projecting outwards and it's saying Kubernetes starting. Let's wait for some time. It's gonna start. Until that, let's wait for that. Here you could see Kubernetes running now, and it's up and running. You can see that green color. So enable Kubernetes. So now we should able to see our cluster, because when it starts, Kubernetes single node cluster will be started. So to see that, what we are going to do is we will open a Windows PowerShell and we'll run it as an administrator and save as, clear the screen, and of course it's been configured. We have a config file properly, so the kubectl config file consists of a Docker desktop user and Docker desktop cluster, so no issue at all, so we can easily use it. So kubectl get node, you see that it's a Docker desktop, the node name is Docker desktop, and then status is ready, and then role, of course we have, it's a single node, it's a control plane as well as the, so both it will do all. So version 1.25.4. so now let me check. So we have our cluster that's up and running, so no issue at all. kubectl get node, so we have our cluster up and running. That means in sticky note, the first part, creating a single node cluster, has been done. So now the second activity to be done is to create our first deployment. So a Kubernetes pod, a pod is a group of one or more containers tied together for the purposes of administration and networking. So the pod in this tutorial has only one container, like this. I'll show you that. So like this is our working node. Let's consider this as a Docker desktop working node, and then we do not have all other pods at this moment. We have only one pod, and inside that we have only one container. So let me get here now. So a Kubernetes deployment, it is one object. A Kubernetes deployment, what it will do is it checks on the health of your pod and restarts the pod's container if it terminates. So deployments are the recommended way to manage the creation and scaling of pods. See, in spite of direct, you can create a pod object, you can create a replica object, but in spite of directly going for the pod object, if you use a deploy object to create your pod, so the more benefits or more features you can get. It's like you can scale it up using replica set, and you can manage them you can upgrade them, you can do whatever you want. So that's the reason even here also I'm going with the with deployment only. So what I'm gonna say is kubectl create deployment. So let me clear the screen. I'm gonna say kubectl create deployment is the, and the name I'm gonna give for this is hello is fine, and hello docker or hello docker desktop, because this is what the hello docker desktop, hello dd node. Okay, that's what the name. And then the image I have to get it. So image I will get it from the registry dot k8s dot io /e2e, and it's a test image. Basically these are the test images specifically made to for the learning purposes, and and name of the image is agn host. Its version is 2.39, and give a space option and /agn host, and it's netexec, and the host port http port I'm gonna go with is http port 8080. That's it, and let me click. So our deployment.apps, so hello dd node has been created. So the name of the deployment object is dd node. So here you could see that deployment.apps, and here you can see that. Now what I'm going to do is I want to view the deployment. To view the deployment, I will say kubectl get either deploy or deployments, whichever is fine. So we have a hello node. This is old one, 91 minutes ago. So here we have created just now 31 seconds ago. The age is just 31 seconds just now. It's hello dd node. It's dd node. So now it's clear. So it's ready. No problem with the deployment. That means it might have, this is deployment object. This is not pod. This is not pod object. This is deployment object. When you deploy it using deployment object, the pod will also be created. So we will look into the pod now, but you can see that it's ready and up to date, and it's available. Desired state and then current state. So everything is done. Now let's view the pod, because pod is part of the deployment. So now I'm gonna say kubectl get pods or pod, whichever is defined. So here you should see the pod name is hello dd node, and then some random characters and random numbers, and then this. Okay, this is the name of the pod. You can see 102 seconds restarts. We haven't restarted it again. So at this, the status is running. It's ready. No problem with our pod also. So it's a single container pod. You can see that on the screen. This is our Docker desktop node. Let me put all together. Let me put all together. kubectl get node. This is a Docker desktop node. Here it is, control plane. And then kubectl get deploy. And this is hello dd node. So this is our deployee object. This is a deploy object. Now let's see the kubectl get pod, and this is our pod. You see that? You can see on the screen, this is our docker desktop node, and this is our pod. Okay, now let's also see kubectl get events. A lot of events are there. So basically scale up replica set hello node. So replica set is also mentioned. If one has been deleted, other one will be created automatically. So let me clear the screen first, and if you want to describe that, you can do that. kubectl either deployment, or let's do that for the deployment. kubectl get deploy and hello dt node. kubectl get describe its deployment and its hello dd node, and this is, so it's normal scaling replica set. And so how many? It's one, just one. Let's scroll up and we should able to see more information. Host port, image, you got the image. Okay, and port, host port, nothing. And environment variables, mounts, volumes, nothing, completely empty, other than the http port is 8080. Rest all fine, so nothing much to replicas, one desired, one updates, and one total, one available. So selector app hello dd node. So rest all it's fine, there is nothing much to view here. Okay, all done. Now it's time to expose. Okay, let's get into this. Create deployment is done. Now it's time to create a service. But why do you need to create a service? That's my question. See, when you're working on the Kubernetes, just randomly finding code and then executing that code, no, it doesn't work that way. You have to understand why you're doing that. Why do we need to create a service now? You tell me. Tell me first. By default, the pod is only accessible by its internal IP address within the Kubernetes cluster. To make the hello node, here this is hello dd node, that's a deployment container accessible from outside the Kubernetes virtual network, you have to expose the pod as a Kubernetes. That's the reason we are creating a service objects. There are a lot of objects in Kubernetes. Every object has a specific meaning, specific functionality. You should know that functionality very well when you are working on the project. So why do we create a service? All definition files of object look similar. It doesn't mean they are same. You should understand their purpose and functionality. That's the reason in my Kubernetes part I have clearly explained each and every object separately, and we have done 2 to 3 examples for each and every object separately. So now let's get into the action here. Enough of daunting. So let's create a service so that I can expose this application to the external world, probably to you. So I'm gonna say kubectl expose, and how it is deployment, and what's the name of the deployment? Deployment. So it's on top, but I remember that it's hello dd node. That's the name of the deployment. And what type of service I want to use? We have seen 3 types of services: node, port, cluster IP, and load balancer. I always prefer load balancer. Here I am gonna use load balancer only. So type is equal to load balancer, and port 8080. That's it. So the type load balancer flag here indicates that you want to expose your service outside of the cluster. The application code inside the image, that is only listens to this port 8080. So if you used kubectl expose to expose a different port, clients could not connect to the other port. So that's the reason you have to give the default port only, that's 8080. So let me click enter. So service, and then the name of the service hello dd node has been exposed. Let me view the services first. kubectl get svc, that's fine. And you see load balancers, we have three. One is Kubernetes. This is a cluster IP. Okay, it's a fundamental, it's a default one. And hello node, this is old one. It's 97 minutes ago. And we have hello dd node. You see that dd node, Docker desktop node, and then a load balancer. And external IP is still pending. If it is not, if it is still pending, means we cannot expose our app. So cluster IP is this, port is this, but it should be. Let me rerun it and see. Let's see now. It's still pending. What I'll do is I will delete this, because both here only one local host we have, right? So let me delete this. So kubectl and delete svc hello node. So service hello node has been deleted. Now let me cross check kubectl get svc. That's it. The load balancer has been, the local host external IP has been allocated to the load balancer. Now we should able to access this at 8080 port and then local host IP. Let's see what's gonna happen. Get into the browser and click local host, yeah, and 8080, that's what we want, and click enter. That's it, successfully deployed. And you see that now the time is so this the date and then time and UTC also. So let me refresh it. Changed. Let me wait for a few more seconds and refresh it. Change 15 seconds, 17, 18, 19, 20, 21, 22. So that means my app is up and running. You see that? So we have deployed. When we are deploying that, we have dealt with both a replica set object as well as the pod object. Once the pod is up and running, then we have created a service we have exposed the deployment to the load balancer service. And then here it is. Here we should be able to expose that application outside the cluster. So now let's say kubectl get services. That's the other way of getting the services, and similarly you'll get the same response. And then external IP is the local host. So that's it. Let's clear that everything whatever we have created so far. So we will remove all those things. So now if you want to see all, we can say, let's before cleanup we will say kubectl get all, and you can see all deployments. We have hello dd node and hello node. Two deployments we have. All two deployments are shown. And then we have two services, default cluster IP service and then load balancer service. And then here you should see pods. Okay, replica set. These are replica sets, basically replica sets. That's what I'm saying. This is the fun of this thing with deployment. Okay, with deployment we are able to see kubectl get. You got the pods information, you got the service information, you got the deployment information, you got the replica set information. See, this a replica set we haven't created, pod we haven't created directly. These were all created by the deployment only. When you deploy, so by whatever, if the whatever things that you have mentioned in that file regarding the pod and then a replica set, all will be executed, and you should see the pod as well as a replica set as well as deployment. And then finally we have exposed this to the outside the cluster using load balancer service. So here in front of our eyes we are able to see four objects: replica set object, deployment object, service object, pod object. I think it's pretty clear now. So now I'm gonna clean up. So kubectl delete service, it's hello dd node. That's it. The service has been deleted. If you want to cross check, you can cross check, but let me delete deployment also, and then delete. No. Okay, I deleted only service. That's fine. So, but what I want to show is I forgot actually. So I will. So we have created a service accessed through the internet, and then before cleaning up, I want to do one more thing. I want you show the container. Show the container which is running inside my pod, inside my Docker desktop node or working node, not working node. Okay, so let me show this, but before that let me run yeah, let me create the service again. Yeah, now we got the Docker get svc and use no, oh sorry, not Docker, it's kubectl. Yeah, here hello dd node. So now let me show the image first. See, this is how a working node, and then inside you will have a pod, and inside the pod you will have a container. So that's what the representation. Now I'm gonna show it live. Brace yourself for the fun, huh? I'll show it live. I'm going to the Docker desktop. So here, to see the containers which are inside the pod, we need to check this one. That's a show system containers. This is a pretty advanced one. When you check this, it will show Kubernetes internal containers when using Docker commands. So now I'm going to say apply and restart. Let's wait for, yeah. So I think it's got applied. So now let me get into the Docker space. You see that? So these are images. I'll show you image one by one. The first one is Kube API server. Did you remember this Kube API server, which will be there inside the master node? And then you see that Kube proxy, which will be inside the working node. Kube controller manager, part of master node. Kube scheduler, part of master node. Kube etcd, part of master node. And pause and some other information, some other images which are belongs to that. Now let me get into the container, and I'm gonna say, so Kate's pod hello node. This is hello node. This is previous one. I want hello dd node. Here it is. You see that? Hello dd node. What I'm showing it to you is a container which is inside this pod. I'm showing it to you. Is it? I hope I think you should get more excited now because you're seeing a container inside the pod, which is not normally possible. I'm showing it to you now. So this is what is the container pod. See, K8 pod. You see the name? It's a K8 pod. Inside that pod, you have a hello node, and this is that, and it's running. So now let me say view details, and this is K8 pod. Inspect terminal status. Okay, and let's get back to the containers and K8. Yeah, this is our pod, and this is the container which is running inside the pod. Now hello dd node, you should see that hello dd node, both were created just 18 minutes ago. I'm going to view details and see the logs, because that's the container which is running inside. So now I've shown pod, working node, and container which runs inside that also. So these are the container logs. So what had happened initially, it started HTTP server on port 8080, then on port 8081, that's UDP. Let me go to the inspect. In inspect, you will find all this information. Hello node port and Kubernetes port, a lot of environment variable you should find out here. Okay, path and ports bounded, and etc host mount points also you could see that. So now let's get into the terminal. As usual, the terminal, it's similar to that. Let me say ls and pwd, present working directory is root virtual directory, and when I say ls lrt, and you should see all the directories: tmp, var, srv, opt, mnt, media, home, localhost, lib, bin, usr, sbin, sys, etc, everything. So, and you can also check the statistics. It's a 9.1 MB memory usage. So now let me get back to that. So here we have seen a working node, a pod, and a container which is inside that. So this is a pod. That's a pod hello node. Let me get the pod name also. kubectl get pod, and this is what correct hello node 24 sln, and you see that 24 sln, this is the pod k8 pod hello node 24 sln. You got it? So this is our pod. You are able to see our pod also. So now you can start and stop the pod from here. You can restart the pod from here. And similarly, this is our container. You can start and stop the container from here also. Okay, so let me restart the container, restart the pod from here. The pod has been restarted. It's just 0 seconds, and the container I will also restart. So let me get into the, and let me say, and here is that pod, yeah, running. That's it. So this is how we can see our pods, and with this we have demonstrated this also. So now let's clean everything. So it's time to clean up. We have seen too much. It's time to clean up. So kubectl delete svc, okay, I'll mention service directly, and hello dd node, then kubectl delete deployment hello dd node. That's it, and the pod automatically will get deleted. That's a kubectl get pod. Yes, it's gone. you got a hello node, a normal one. So let me delete all those things also. Cube delete. So service. So no service such deployment. Let me check. So deployment has been deleted. So now we should not have any pods now anymore. So let me say kubectl get pod. So no resources found in default namespace. So now let me get here. So you should see images, those were copied, so they will be there in local machine. Whereas let's come to the container. So dd node, these are in exited state. You see that they are also going away. Okay, now only this hello node has been left. I think this is pod, hello pod, that also should go away, na? Because rest all gone. So kubectl get pod, I think kubectl deployment, it's deleted. Okay, no resources found in default namespace. This should also be deleted. Okay, what's wrong? Let me show. Yeah. Okay, it's not getting deleted, but it's an exited state. It's gone. So let me delete it manually. So that's it. Cleaned up. So we have seen pods. We have seen working node or node, and we have seen a container inside the pod visually. We have experienced it, all those things. Till now these are all abstract things. They are somewhere else. We have never gotten the concrete feel of looking into the container pod. So now I have shown it, I have shown that also. So now let's meet in a second exercise of Kubernetes. We have seen Hello Docker desktop deployment object in single node cluster using Docker desktop and Kubernetes extension. Now we will be creating a cluster using minikube, and we will be we will be working on various objects of Kubernetes, such as services, deployment, ingress, lot, pods. So but before that, we should understand what is minikube. So the name itself says minikube is minikube is a local Kubernetes focusing on making it easy to learn and develop for Kubernetes. So here we need some prerequisites to work on that. So first I will write those prerequisites. So what we need is okay, first let me put heading. It's minikube. Prereqs. First, minimum 2 CPUs or more, 2 GB of free memory, 20 GB of free disk space, then a proper internet connection, then the most important one, you should have either a container or a virtual machine manager, either container or a virtual machine manager, such as Docker, hypervisor, KVM, Podman, VirtualBox, that Oracle VirtualBox, VMware Fusion and Workstation. So here we will be doing two examples. So first one we will be working on with Linux, that is Ubuntu, and second example is going to be with Windows machine. Yeah, this is with Windows machine. First we'll do with Linux, Ubuntu. So obviously for Linux we will take a container, a docker, we'll take docker. Whereas for this one, either we'll go with the virtual machine manager such as Oracle VM virtual box, or a simple docker again, whichever uh, goes well, they will go with that. Okay, so for now first we will look into the Linux machine. Okay, so hands on, getting started with minikube. The first step, the first activity in this is to create a minikube cluster. So that's what we are going to do. So we will be working on Linux machine. You see that Linux machine, and so this Docker will also be a prerequisite in addition to these four. So in this, what is my first step? Step one is to create a minikube cluster. Okay, so now to create a minikube cluster, what I have to do is first I have to set up AWS EC2 instance, and that should consist of with uh, 2 CPU, 20 GB, and I'll go with the Ubuntu. Okay, so and once EC2 instance has been created, then we will log into that, login, and install minikube, and also we have to install docker. So this is the first step, and once all done, then we will say minikube start. So these are part of step one. So first we'll finish with the step one, then we'll go to the step two. Okay, so let me get into the EC2 instance to begin. So this is my AWS, and in this I'm gonna create an EC2 instance. So launch instance, click on launch instance, and name I'm gonna give mini cube server. So Ubuntu, I'll go with the free one, 20.04, and canonical, that's AMI image ID. And here I'm gonna go with what's our requirement. Minimum requirement is 2 GB, so I'm gonna go with 2 GB and 2 CPU. So T2 nano, T2 micro is 1 CPU and 1 GB, and T2 small 1 CPU 2 GB, T2 medium 2 CPU 4 GB. I'll go with the T2 medium, where it consists of 2 CPUs or more and 2 GB of free memory. I will go with the 2 CPU and 4 GB memory. Okay, then T2 T2 medium is done. Let me create a key pair. I'll say mini cube key, and click on create a pair. And now let me edit network settings, scroll down. So it's mini cube SG, and same, copy here and paste it here. and the first security group role will keep it same default one, so that we can do SSH into that machine and we can do required operations. And second one, we will make it uh, type all traffic, yeah, port range all, and source type my IP. That's it. These are the two. Absolutely fine. So nothing much. Let us launch. Okay. Storage volumes. One more thing is add volume. So at this moment we have one. So let me make it to, see, you see that it's a GP2, general purpose SSD. That is okay. So I'll make it into more than 20 GB. Okay. 30 GB. I'll make it 24 is also fine. That's it. That's fine. So now let me launch an instance. So meanwhile, let me get the, okay. So meanwhile, let me get into this, and here I'm gonna create a directory saying minikube, and here I will put my file. It's downloads, and fetch this one, Control X, and minikube, paste it here, make it, minimize that. Okay, by the time our instance is ready, yeah, minikube server is up and running. So let me go to this and pick this, copy this one, SSH command, and let me open git bash here, paste it, and log into the system, say yes, and sudo option I, clear the screen, ls. That's it, nothing much. Now it's time to fulfill our prerequisites one by one. So all these three, all these four were fulfilled. So next thing is installation of Docker first, and after that installation of, yeah, here it is, installation of minikube, and then installation of Docker. So let's install Docker first, and then we'll install other one. So for that, I'll come here. Mm, so Docker installation, Ubuntu directly, install Docker engine Ubuntu. So this is installing Docker engine on Ubuntu. Okay, we have to select this, not Docker desktop. You have to be very careful when doing this. It's Docker engine. So first, let's uninstall if there are any old versions. Of course there won't be any old versions because we have freshly created that instance. So now let me use this method. So first let us set up the repository for that, and we need to update the app package index and install packages to allow app to use a repository or HTTPS. Let me copy all those things and directly paste it. And when it asks for permission, just say yes. And meanwhile, let's look into the other steps. Yeah, let me say, that's it. It will get installed by the time, yeah, it got installed. Then after that, it's time to add Docker's official GPG key. So let me copy that and paste it here. So official GPG key has been added. Next, use the following command to set up the repository. That's it. The main thing, var lib docker and that's also done. Then it's time to install the Docker, but before that we have to update the index of the apt-get package or apt package, whatever the one which we are using. Then let us also give permissions to that keyrings Docker. Okay, then that's also done. Index has been updated even after giving the changes. Now let me use the command for Linux. It's the to Ubuntu Debian based. Just copy this here. Docker CE, CLI, container, and all information. Okay, let me copy this and paste it here. Yes. Okay, processing triggers for mandb. Okay, it's done. Let me say docker start systemctl start docker systemctl enable docker done, then systemctl status docker. That's it, it's up and running, so no problem with this. So now let's, what's next step? Next is to install cube, install minikube. Okay, minikube. So to install minikube, let's get into the documentation of installation of minikube again. So this is minikube start. You see that this is the installation procedure, step 1. So whether you want Linux or Mac OS or Windows, this is for Windows. At this moment we are not going to work with Windows for now, so I will go with Linux. So when you click on Linux, you have few options. Installer type, either you could go with the binary or you could go with the Debian package or RPM. Anyway, we have only two options, as it is ours is Ubuntu. Either I can go with the binary download and place it in the proper directory, or use the Debian package. So I'll click on Debian package. It's much easier. So I'll just copy this and I'll paste it there. Curl, it's basically fetching that file, and once it is done, after that it's set up the unpacking the minikube and setting up the minikube. So now let me say minikube. Yes, it's there. Minikube, it's there. Minikube start. Now let's go through the minikube commands, basic commands. So minikube provisions and manages local Kubernetes. Basically, this is not for the production ready or production level clusters. This is for local Kubernetes clusters which are optimized for development workflows mainly. And so let's go through the commands one by one. Let me select. So first start, it starts a local Kubernetes cluster. Then we have status and we have stop. It stops a running local Kubernetes cluster. Then delete, it deletes a local Kubernetes cluster. Then dashboard, it accesses the Kubernetes dashboard running within the Kubernetes minimum cluster, within the minikube cluster. So then we have more images. For images, you have to give docker and podman and add-ons config up and update context and all. So with this, our installation is successful. Now it's time to create our cluster. So from this terminal with admin, we can create our first cluster using mini start. minikube start. So minikube automatically set to the Docker driver. Docker driver should not be used with the root privilege if you wish to continue as a root. Use force. Okay. Minikube start and driver none. Okay, now it's pulling the image and starting that. Let's wait for the Kubernetes minikubes cluster. So if you go through that, so minikube, this is version is 1.29.4 on Ubuntu 20. So minikube skips the validation. Then the Docker driver should not be used with the root privileges. So we have done force. So then it started pulling the image. Now it's downloading the Kubernetes version 1.26.1 preload. So images, yeah, now images has been pulled. One is preloaded image KHB1H and the other one is KH minikube KIC base. So now once this is done, so it's basically creating a Docker container. So for that, what we require is minimum to minimum CPU, 2 core, and you need a memory of at least minimum to minimum 2200 MB. So that's more than 2 GB, at least close to 2 GB. So that's the reason I have mentioned this here. You see that? I have clearly mentioned the requirements. The 2 GB of free memory and 20 GB of free disk space. These are minimum requirements to create your cluster. Of course, the cluster means it's not, you won't have a lot of machines. You'll have only one uh, uh, single node cluster. This is a single node cluster. So by the time, so a lot of action is taking place. So create, okay, done. It's done. So kubectl is also configured to use minikube cluster and default namespace by default. So all done. So no issue at all. So initially kubectl not found. If you need it, try minikube kubectl get pods option A. Okay. Let's let me check that because we kubectl get node. Let me install kubectl also. We did not install kubectl till now. So once the cluster has been created, so then we have to install kubectl also. So but before that, let's see the cluster. Let's see the cluster first. Let me clear the screen and let's see the cluster first. To see the cluster, as we need to use a kubectl. If you want to do any operation, we need to use kubectl as they have mentioned. So that's the reason now it's time to install kubectl. So let me write that here. So in addition to this, so rest all are done. Minikube start is also done. Then it's time to install kubectl. So let's get into the documentation for the installation of kubectl. Click and kubectl install Ubuntu and install and set up kubectl on kubectl on Linux. So let me come to that. Install kubectl binary with curl on Linux, or we'll use a native package management. Anyone is fine. Okay. And other one, yeah, here you should see install using native packagement. This is for Debian and this is for Red Hat. So I'll go with the Debian and I'll go with the package management. So what we are doing now is we are installing the kubectl because that's also very important prerequisite. So Docker as well as kubectl, okay, and minikube. So these are minimum requirements. So all are done. Cluster is also started, but installation of kubectl is left. Now we are going to do. So first we will basically update the app package and package index and install packages needed to use the Kubernetes repository. We will do that first. Let me paste it. Yeah. Then by the time we will also, if we use Debian, okay, this is for Debian 9, so we are not worried. So then we have to download the Google Cloud public signing key. So let me copy this and download the public signing key so that the proper secure way of connection will be established with the Google Container Registry GCR. So I think okay, done. Let me put this also. Yes, this is also done. So Google security signing key is also done. Now add the Kubernetes apt repository. Let me add this repository, apt repository. So copy and paste it here. Oh, this is also done. Now let me finalize the installation of kubectl by updating the apt package index and with the new repository and saying the install kubectl and paste, and installation is going on. I'll say option Y apt get install. Okay, option Y is the kubectl. Yep. So installation of kubectl is going on. So kubectl has been successfully installed. So now let me mark that also. So now all prerequisites are being met. So we have Docker, kubectl, minikube, and we have our cluster running. So now let's cross check the cluster. So let me say kubectl and I'll say get PO and option A. You see that all the pods all are running. So these are all kube system. Basically these are all kube system pods. You can see that API server, this is API server of minikube, and this is controller manager of minikube, this is proxy of minikube, and this is scheduler minikube, and this is storage provisioner. So these are the etcd also. You see that etcd. So whatever we have discussed in let me show that. Yeah, so whatever we have discussed, similar kind of architecture will also be there in minikube. So this is our API server, then controller manager, etcd, scheduler won't be there. So remaining, and you will have a proxy. So all that things will be available in this. So that's what you're seeing here. Okay, now what will we do is we will keep this aside and we will try to look into the cluster first. Okay, kubectl and get, I'll say node. You see that the node name is minikube and status is ready, roles are control plane, and 6 minutes 45 seconds ago. Absolutely fine, absolutely fine, brilliant. So our cluster is up and ready. So now it's time to run our definition files, create our definition files, and create our Kubernetes object. So before that, if you want to explore more, we can explore just two 1 minute I'll take, and I'll take you through this. Okay, let me clear this. Let me say kubectl get ns. So these are the basic namespaces, the default namespace: kube node lease, kube public, and kube system. Kube system is specific to the kube system, consists of all pods that are related to the minikube or anything, any system. Okay, then I'll say kubectl get deploy. So no deploy. Kubectl get svc, should not be any, but one default service will be available, which is the cluster IP type. Then kubectl get pods, we should have some pods, no resource pods, and kubectl get secret. So nothing, you'll find namespace, deploy, secret, service. So replica set also we have seen enough, so we have explored. Nothing is there other than the namespaces, they are default. Okay, so no objects has been created so far, it's completely empty. So now we will begin with our first application deployment, that is hello minikube. That's what our first one. So hello minikube. So ls, so we have this minikube latest AMD 64.deb. This is the binary file of deb package. Okay, now what I'm gonna do is I'll get into cd home and ubuntu. So here I'm gonna create mkdir minikube. Okay, so cd minikube ls, nothing is there. So here I'm gonna create all my projects, all my minikube projects, direct minikube project directories. Okay, but before that, let's get into our ppt. So here, where are we now? Yeah, minikube, this is the slide we are. So the first one, creating a minikube cluster is done. Now the second step is to create a deployment. So basically, if you create a deployment, it's gonna create a pod object and a replica set object also. So, and once you create the deployment, you have to view the deployments saying kubectl get deployments. And okay, now, and at the same time, if you say kubectl get pods, you could view the pods also. That's the second step, and you can use the config using kubectl config view. Okay, so the second step that we are going to do is to create our deployment. So let me write the same. The second step, first step one executed successfully. Second step is to create a hello mini cube deployment. Basically here we are gonna write our definition file for deployment, and then we will create the deployment object. So when you create a deployment object, by default you will also, pods will be created and a replica set will also be created anyway. So let's begin. We will write our first, we will create our first deployment. Okay, let me clear the screen. So kubectl and create, we are going to use a create because we want to create. So create and deployment type, create deployment, and name is hello mini cube. And after that we have to provide the image is this image, it's image equals to kic and base, kic base / echo server. That's what, echo server, and echo server tag is 1.1. So that's it. Let me execute this first and see what's going to happen. So successfully hello minikube has been created. So now let me say kubectl get deployment. Deploy is fine. So hello minikube is the deployment object. That's one, it's ready and it's up to date and it's available, so no problem at all. So now let me check the pods, how many pods we have. Kubectl get pod, let me enter. Yes, hello minikube 77b6f68484 is one pod was created after while we are creating the uh, hello minikube deployment object. So 34 seconds ago it's been created. So that's hello minikube. And let us check the replica set. Do we have any replica set? Get rs. Yes, there is one replica set, that's hello minikube 77b6. It's the same, it's the pod name, and this is same. No, it's not same. The few more additional characters are there, and this is a replica set. It's a different object altogether, but the replica set here we have mentioned the replicas are one. So that's the reason all desired one, current one, ready one. So that's it. We have seen our we have our pod is running, our pod is running, container is running, and now if you want you can only look into the event deployment is running. So kubectl get pod, and this is that one hello minikube. If you want to check whether it is healthy or not, kubectl, then you can say describe pod. It's just I'll copy the name and I'll paste it directly. Yeah, yes. So you see that no issue at all. Created container echo server and started container echo server. So rest all is absolutely fine. It's no issue at all. And volumes, everything is mentioned. That's okay. So now let me clear the screen. And anyway, we'll see this step has been completed. That's the creating step 2. Hello minikube deployment is done. Now what's there for the step 3? So basically you can, if you have seen all those things, and the kubectl config view if you want, that also you can see. So second step is also done. Now let's move to the third step. What's there up? The third step I'm gonna do is create a service. The deployment has been created, pod is ready, replica set is ready. So now it's time to create a service. So what a service does, it exposes the pod to the public internet using a kubectl expose deployment hello node. So let's do that. We will give the same command and we will expose it to the, so the service that we are creating here is a node port type, and it's imperative way of doing the same thing. You can put it in a file and you can do that, but however we are doing it in imperative way with a command. So kubectl, so expose, and what we want to expose, deployment. And what's the deployment name? It's hello minikube, correct? Hello minikube. Then we'll give type, what type of service you want to create. I'm gonna go with node port. That's the simplest one. First we'll go with the node port, and we will, and at what port you want to have your pod running. So port 808, so 808. So that's where I want. So that's done. Now it's time to create our service, and service name we have given as hello minikube. Okay, expose. Okay, let me click execute. So service hello minikube has been exposed. So now let me say kubectl get svc. You see that hello minikube, and this is the cluster IP and port we should we should access this port to get our application. Okay, we should access that. But before that, if you want to see something, if you want to describe this new service, you can do that. So kubectl describe and its service. Then we have the name, that's hello minikube. So that's it. This is the information about uh, service and what it consists of. Namespace is default, I have shown you earlier, and then labels app equals to hello minikube. And what is the type of the service? It's a node port service. What is node port? Node port is basically mapping one port of the node with the other port of the node through these through the IPs and ports of the nodes. So, and here you should see the target port, but what's important for us is endpoint. This is the endpoint. This is where we can access our application. Okay, then okay, that's it. So now let me get into the EC2 instance, connect and instances, and click on here. So 15.206.73.37, and here, so 50. Okay, now what I'll do, I'll take that IP, public IP, I'll paste it here, and it's 8080, correct? Okay, let me get into the instance. Yes, it's wrong. It's 15 to 206.73.37. That's the public IP of this. Let me paste it here, and 8080, that's what is our, and here is, so now let me refresh it. There is some issue. Let me cross check that. Maybe let me check the pods. Service is running fine, because endpoint we can see that, we can see the endpoint absolutely fine. So what I'll do is I'll just check the, I'll attach uh, security group to this. One more security group, and inbound, edit inbound rules. So that's all traffic is my IP. This is also my IP, and I'll add one more rule, custom, and this is 8080 my IP, and let's save it. So that's it. Let me zoom it. Hello Kubernetes. That's it. Deployment, a proper way of deployment and expose. Now let's look into the one more tool that we have in our pipeline. So far we have seen the hard way of setting up our Kubernetes cluster. Then we set up a cluster using Docker Desktop and its Kubernetes extension with the help of kubectl. And we used minikube to set up the cluster, and we have deployed an application inside that single node minikube cluster. So now it's time to think big. It's time to do big. We are gonna do big with Kops. So a Kops, a multi-node Kubernetes cluster on AWS. We are going to create a multi-node Kubernetes cluster on AWS. So here in Hands On Kops, we will use Kops tool to create a 3-node cluster, a Kubernetes cluster, and inside that we are going to do 3 to 4 exercises such as deploying various applications, various stateful applications, stateless application, and simple Hello Kubernetes applications. We are gonna do all those things. Simply to say, fun is loading. Okay, so let's write prerequisites for the same. So working with the Kops. In Kops, we will begin with the prerequisites. Prereqs. So the main prerequisite is you should have AWS account with root user access. Okay. Then after that, we will begin our work with creating our cluster. Then we will follow step by step. So the first step is to create a Kubernetes cluster to make our hands dirty. So to do all the experimentations on various Kubernetes objects, we require a cluster, a Kubernetes cluster. So that's what we are going to do here. So we are going to create a Kubernetes cluster using Kops and Amazon Web Services. So how do we do it? So to create a Kubernetes cluster, the first step is we need a domain for Kubernetes DNS records. So I have my domain imlike.com from GoDaddy. So you also have to create your own. Then once that is done, we have to create a Linux virtual machine and setup. So here I'm going to use EC2 instance, and inside that EC2 instance we have to install Kops, kubectl, SSH keys, and AWS CLI. Then we have to log into that AWS account, and we have to set up S3 bucket. I am user for AWS CLI Route 53 hosted zone. S3 bucket is to store the state of the objects. Then final step, log into domain registrar to cross check. And once we log into the domain registrar, you have to create NS records for subdomain pointing to Route 53 hosted zone NS servers. So naming servers basically. So naming this NS servers should be a Route 53 hosted zone NS server should be connected with the NS records of the subdomain, so that the EC2 instances which are part of the AWS can be put into the domain of subdomain of GoDaddy, so that we can access these EC2 instances through the domain names using naming server. So let me put these activities into our sticky note, and this is Kubernetes in action. So the first exercise in this is to create a Kubernetes cluster using Kops. So first what we are going to do is we will open GoDaddy and we will create our domain. Then as usual, AWS EC2 instance T2 medium. I'm gonna go with T2 medium, and once that is done, we will also create S3 bucket. I am user and route 53 hosted zone. And once this is done, so we will log in back into our domain registrar, that's a GoDaddy, and then we will point out we'll point out the route 53, or a simple way we'll make connection between route 53 hosted zone, NS servers, and GoDaddy or our domain. Okay, connection. Okay, so these are all steps for now. Then we will proceed further. Once these are all done, we will proceed further. So for that, first we will get into our GoDaddy account if you have one, or else you have to create one account. So let me get into this. This is my AWS instance, and first let me log into GoDaddy. Login. If you do not have, you have to sign up. If you have an account, you can sign in. So I have my account, I have signed in. So now here type the domain you want. So I have my domain imlike.com. If you want to create a new domain like cherry tails, this could be the start of something. So you can find out some cherrytails.com, cherrytails.in. So a lot of .co.in, .co.tv, .shop, .club. So a lot of domains are given. So this is exact match. So if you want to buy it, you have to click it, make it yours. Then you have to continue to the cart, and then you have to pay money. It's 139 rupees for the first year with a 3-year registration. Okay. However, I have my domain, so I'm not going to go with that. So I will use my domain itself. Okay. You have to create your own domain if you do not have. So my domain is imlike.com, because my domain belongs to machine learning and artificial intelligence. So that's the reason I have taken imlike, MLAI. Okay. So let me click OK. And these are all some other, this domain taken, this imlike.com, that's mine itself. But now the charge is, now it's pretty costly. It's 5,249 rupees. We might be able to help you get it. See how. Let me click how to get it. So here is how this works. You get a dedicated domain broker. When you purchase the service, a dedicated broker will help you formulate a strategy and budget to try to acquire your domain. So basically I have taken this domain now. So if somebody wants a similar kind of domain, so some dedicated domain broker will be allocated this work. So he will set up that meeting with the other person who is basically having this domain. So he will talk to the both, and he will create and he will come up with the final solution, and somehow you'll get it. The domain broker works the deal for you, and the domain is securely transferred to your account. That's how it works. If somebody wants my domain, so you have to just ask for add to cart, and the domain broker will speak to me, and then if a deal is struck between me and domain broker, and domain broker will pay that money to me, and then it will securely transferred. The domain will be securely transferred to the new person, whoever wants that. However, this is my domain. Now it's costing 5,249 rupees, but before I purchased it at 139 rupees. That's fine. Okay. So now let me get back. So yeah, go back to the work. Yeah. So here you can see this is my, so just click my products, and here you could see account alert, keep you up to date, add SMS alert. That's fine. Okay, this is my domain. So I have my domain, so I don't need to create. If you do not have, kindly create your domain. So if I click on DNS, I have some existing naming servers. I'll delete all this. TTL, okay. So I have some existing naming servers, and okay, this 6 DNS records has been deleted, and I'll delete these also, so that when we are working on this, it would be pretty clear for you, or else you will get confused. So that's the reason I'm deleting the existing, yeah, 5 new DNS records also has been deleted. So yeah, now I do not have any, uh, yes, any DNS domain naming system records. Okay, nice. Yeah, DNS records. So these are all default one. Let's keep it. Okay, you've seen my DNS, and you should also get similar page for your domain if you have created, and you can click on manage to get into more information about your domain. So okay, just come here. This is all about your domain, forward domain, manage DNS, and if you click here and here, you will have your May emails with imlike.com with your domain name. I think it's pretty clear now. So I hope you also created a domain name with this account. So let me mark up this. So the first one, let's open GoDaddy and create our domain. So the domain name should be remembered. It's imlike.com. So let me copy this and keep it in sticky note. This is what my domain is. Okay. So now what's the next step? It's time to create our EC2 instance. Now let's log into our AWS account, and we'll create an EC2 instance. So this is our AWS EC2 instance, AWS account, and this is our AWS console. And if you do not have AWS account, kindly create AWS account and then join with me in this session. So I will click on EC2 instance service. So this is Tokyo. I'm gonna go with US East 1, East 2, Ohio, and West 1, West 2. I'm gonna go with US West 2, that is Oregon. Yeah, here I'm gonna launch my EC2 instance. So just note down here, it's US West 2, that's Oregon. That's the region, and this is Kops. The name of the instance I'm gonna give is Kops. That's a KOPS, Kops. I'll go with Ubuntu 20.4, 20.04, and here I'm gonna give T2 medium, then key pair. I'll create a new key pair, so I'll say Kops key. Yeah, then network setting, I will go with the simple network settings, only SSH, nothing much. Kops SG and Kops SG. So this one my IP and rest all remains same. So let me launch this EC2 instance. By the time I'm gonna take, okay, so EC2 instance successfully initiated, it's been initiated. So now let me go to the downloads and take this kops.key and let me put it into create cluster. So this is where I'm gonna put my kopskey.pm. So that's it. Let us check. By the time it gets and it's up and running, we will do other tasks. So this is done. The first step is done. Second step, AWS EC2 instance creation is also done. That to T2 medium. So now we are gonna create S3 bucket first and IAM user, then route 53 hosted zones. Okay. So let me, yeah, I'm here only. So now S3 bucket. Next one is S3 bucket scalable storage in the cloud. Let me click on S3 bucket service in AWS services. Now you can see that Amazon S3 store and retrieve any amount of data from anywhere. If you want to go through this, you can go through it so that you'll get a clear-cut understanding of what is S3 bucket. But for now, we will create our bucket. So name of the bucket I'm gonna give is vprofile Charan Kops state, because this is vprofile, this bucket we will be using it to store the state of each object. So that's the reason the name we gave as a vprofile Charan Kops state. Okay, so we have created S3 bucket and we'll put it in US West, Oregon West, US West 2. Fantastic, you don't need to touch it. Region is also fine, and rest all you can keep it same or default settings. You don't need to attach anything else. Rest all will go with the default settings. Okay, rest all fine. Let me create a bucket. So name of the bucket and region of the bucket are important for us. So now successfully created bucket. Bucket name is this vprofile Charan Cop state. Let me copy this. No, this name I just want to copy this bucket. So put it in here. Yeah, this is our bucket name S3. Next, S3 bucket is done. Now it's time to create IAM user. So let me go to IAM services. Why do we require IAM user? So we want to access AWS, our AWS account from some other instance, some other machine. But how can you do that? So the only option is you have to create an user and then you have to give access to that user, and the security key, the access key should be stored in a machine from where you want to access this through AWS CLI. For that, you need to install AWS CLI in another machine, and there you have to provide the security keys of this user, so that from that, as a user, through your AWS CLI, you can access your Amazon Web Services account from a third machine or third party machine, or the machine which is not directly connected with the AWS. Okay, so now let's create a user. Let me click on users first. So we have IT admin, Terra admin. So now we are going to create a new user named Kops admin. So the name I'm going to give is Kops admin, KOPS. Let me make it small. Kops admin is the name. So enable console access optional. That's not, console access is not. For programmatic access, you can generate access keys after you create the user. So let me click next. Let me click attach policies directly, and what policy I'm gonna give is administrator access. So AWS access type programmatic access, and then permissions I'm gonna give administrator access. Rest all fine. Permissions boundary is not set. We'll keep it same, optional. Then we'll go one step ahead, and now you can see review and create administrator access tag is not required because we have attached a Kops admin. Now let's create a user. So now it's creating a user. User has been created successfully. You can view and download user's password and the email instructions for signing into the AWS management console. So let me either click here view user, or else we can click there. Yeah. So now here we can find out a security credentials. Okay. Let's enable console access, or else we'll directly create create an access key. So access key best practice, that's okay. Let us directly create a CLI, command line interface access. Okay. And click next. And check I understand the above recommendation and want to proceed to create an access key. So key, the name I'm going to give is Kops admin access, and create access key. So it's been created, and here is that, and you can download the .csv file from here. So cut and paste it in your directory. This is your file, Kops admin, and here you can see your access key and secret access key. So never access key and secret key. So never ever reveal this access key ID and secret access key to anybody. This is very secure and you have to keep it safe. I'm gonna delete this user from this, so that's the reason I'm basically showing it to you. However, I don't encourage you to share this with anybody, even with your friends. So now so the second activity is also done successfully. So now, so S3 bucket is done and IAM user is also done. So, and now the name of the is Kops admin is the name of the user, IAM user. Now it's time to create route 53 hosted zone. Route 53 hosted zone. So for that, I will again route 53. Yeah, we can see that service route 53 hosted zone. Yes. Now we are gonna create hosted zone, and let me click on create hosted zone. So the domain name, this is the name of the domain that you want to route traffic for. So I'm gonna give kube vpro.imlaic.com. Yes, so that's what and it's a public hosted zone, and I'll give the same description. This is hosted zone for kube cluster. Rest all remains same. I'm not touching anything. So let's create a hosted zone now. So the hosted zone has been created. Let me close this. So 0 records. Cube vpro, sorry, spelling is wrong. Let me delete this zone and create new zone. Create a hosted zone. This time at least I have to give proper one. Cube vpro dot imlaic.com. Rest all hosted zone for kube cluster. Create this hosted zone now. Yes, kubevipro.imlaic.com. Everything is fine. So here you can click for the hosted zone details, and these are 4 naming servers. These are 4 name servers that we have, and here you can see that kubevipro.imlaic.com. This is a routing, and these are the 4 naming server, and this is SOA, and this is simple one, like basically, and here this is not the naming server. Okay, so this is also done. So name of this hosted zone is kube vpro imlaic dot com. Okay, now it's time to make a connection between route 53 hosted zone name servers and domain. So for that, what we have to do is we have to copy this. I'll copy all these 4, yeah, and I'll put it in our, yeah, here is fine. Yes, so now let's get back to our GoDaddy. Yeah, here it is, and yeah, this is my DNS, and let me click on DNS, or yeah, now you can see our DNS records. In this, I'm gonna add a new DNS record, domain naming server record. So choose an account. So I'm gonna go with ns, and this one I'm gonna exactly name, I will give cube wipro, and here the first one DNS, let me get here the first, yeah, ns1, then ttl, I'm go with the default, I'm not gonna touch that. Okay, and so let's add this, let's add this record, update a DNS record imlike.com success. So you should find this here. So ns, yeah, ns cube wipro, and fine. So now let's add one more record, again ns name, yeah, and it's the second one, default, I'll go with the default. Done. Next we will attach a third record, ns cube wipro, and default is absolutely fine. Let me, done. And the final record of naming servers ns and cube wipro, and paste the final naming server record, and ttl is default, and let's add record. That's it. All records has been added, and you can see that these are the 4 records has been attached. So now let's get into our sticky note. So the connection between Route 53 host John and NS server domains, Route 53 host John, NS servers and domain has been established. So now let's get into our hosted John and refresh it. Yeah. So far we have done with domain, the first step, and the third step, and the fourth step. Now it's time to do this installation of Kops, kubectl, SSH keys, and AWS. These are the steps left. Let's do that. So for that, the steps follow like this. Let me go back to the AWS EC2 instance step. So here I'm gonna do. So first, once we log into the EC2 instance, then SSH keygen, we will generate that. Then we will install AWS CLI, then AWS configure, then once AWS configuration is done, then we will install kubectl and install Kops. Once installation of all are done, then we will verify the domain and we'll create our cluster. That's it. Once all are done, next the fifth step is to create a cluster and verify our domain. That's it. Okay, let's begin our installations. Let's begin with SSH key gen. Now, but before that, we have to log into our system. Let's get into our AWS and then we'll see what's the condition of EC2 instance. So EC2, I should be in US West 2 region, Oregon. Yeah, it's a Tokyo. Let me change to US West 2. That's Oregon. Yes, here one instance is up and running. So let me click on that instance and click on connect and copy the SSH command and get into my directory where Kops key is there and open a git bash there and then paste the command there and enter. So yep, we have successfully logged into the system. Now let's begin our activities. Okay, now pwd, yeah, it's a root directory, so snap. Other than that, nothing else. So here I am going to create my ssh keygen, ssh keygen, and execute. So generating public private RSA key pair, it's asking the file name. I will give Kops SSH. So enter passphrase. I will give okay. That's it. Our SSH key has been generated, and this is the random art image that you can see here. And let me show you that. ls, you see that Kops SSH, and then Kops SSH.pub. This is our public key, and this is our private key. That's it. So now let's begin our installations one by one. The first installation we are going to do is AWS CLI sudo apt update. Okay, you can see that US West 2, this instance belongs to. Yeah, all done. So now it's time to give, say, apt install AWS CLI option Y. So the installation process has been started and it's being installed. It's unpacking the package. So 95% is done. Let's wait for rest to be done. So but once installation is done, the next task is to configure this AWS CLI with our AWS user that we have created in AWS account, so that we can access our AWS account from this EC2 instance, from this Kops server using, sorry, this is not Kops server, this is just a Kops. From Kops machine we can access that AWS account. So let's give AWS configure. So it's asking AWS access key ID. So we have downloaded it. If you remember, here is that. This is our AWS access key ID. Let me copy this and paste it here. Now it's asking AWS secret access key. Again, let me copy this and paste it here. So now default region name, it's US. Let's confirm one more time. It's US West 2. Okay, US West US West. Yeah, correct. Then default output format, I'll go with the JSON, and that's it. Configuration is successfully done. So now what's left? Let's install one by one. So before that, let's see the status. So SSH keygen AWS CLI installation is done. Configuration is also done. Now kubectl and Kops are left. For the kubectl, let's get into our documentation. Yeah, install and set up kubectl on Linux. Install kubectl binary with curl on Linux. So we have to download. This is common. This is only for Linux. You can use it, or you can just directly come here. Debian based distributions. This is a specific way of doing. But what we are going to do is we will use this directly. Curl instead of using packages. We will use the curl. This is far better. Download the latest release with the command. So we'll use this. Yeah. So get back and paste it here. kubectl AMD64 bin Linux, absolutely fine, stable version. Yeah, that's okay. So now it's being fetched. It's done. Now what we have to do is we have to give permissions to execute this binary file for all the users. So that's the reason I'm going to give +X, and the name of this is kubectl. That's done. Then let's move this kubectl binary file. You can find out here. You see that the kubectl, this file, and if we do lslrt, you could see that for the kubectl we have given execute permission for all. All means all. For the owner, for the group members, and for others, everybody can execute kubectl. So now what I'm gonna do is I'm gonna move this kubectl file from root directory to the, that's a root user home directory, to the binary file, binary directory. So for that I'm putting to user. I'm going to put this into user local and then bin directory. That's it. It's been placed into the bin directory. You could see that no kubectl here. So now let's validate the installation of kubectl. For that I'm going to say kubectl help option. That's it. kubectl has been successfully installed, and you can see some of the commands. So all these commands we are going to use. Don't worry at all. Deploy commands, basic commands: create, expose, run, set, describe, delete, rollout, scale, everything we are going to see. So this is also done. Now install Kops. It's time to install Kops. Let me clear the screen first. To install Kops, so again we'll get into our documentation, and this time I'll say install Kops, installing Kubernetes with Kops. Creating a cluster, Linux. Yeah, so we'll go with the Linux, not and then it's Kops Linux AMD64. Kops Linux AMD64. This is the correct version. So we are going to take this curl. Of course, you will have another ways of installing this using packages and all, but I would love to go with the binary file. That's pretty easier than other ways. So Linux, because I don't this could be this can be used in any Linux distribution. So that's the reason I'm gonna do with this. So again, let me do curl the binary file of Kops AMD64, and let me do ls. Yes, here you should see Kops Linux AMD64. Kops Linux AMD64 binary file is absolutely visible. Now let me do ls lrt and Kops Linux AMD64. Nobody has execution rights, execution permissions, neither owner nor user, neither owner nor group members nor others. So now the first activity that we are going to do is chmod plus execute permission x and Kops Linux AMD64 and execute. And let's cross check that. And here it is. Execute, execute, execute. User, owner, group member, and others all has the execute permissions. Now let's shift this file from root home directory, root user home directory to the binary directory. So Kops Linux AMD64 and / user local bin and Kops. Oh, sorry, not kubectl, it's Kops. So this is where I want to move into the Kops directory, and let me execute this. I think it's successfully moved. Yeah, no file here. So now I'm gonna validate the installation of Kops. For that, I would say Kops and help option. That's it. It's successfully installed, and you can see the available commands of Kops create. This we use to create the cluster, a Kubernetes cluster, and delete to delete the cluster, and we have update to update the cluster, and version. Let's give the version Kops version, and here it is, the client version 1.25.3. and now let's mark this. So installation of Kops is also successful. Now it's time to create a first ever Kubernetes cluster. But before we create a Kubernetes cluster, we will verify our domain also. Okay, we'll verify our domain, whether it's been properly integrated with our AWS Route 53 hosted zone or not. That's what we're going to do. Let's validate that. For that, I would say ns lookup, that is naming server lookup, and option is type. What type you have to look, that is ns naming servers. You look for naming servers, and it's a kube vpro, that's our hosted zone, that's what we have given, and imlaik.com. Correct? That's it. Here it is, server and kube non-authoritative answer, and you could find out that kubevipromlac.com has been connected, because this is imlac.com and this is naming servers. Properly it's been connected. Okay, so we are able to find out the information about this. So we have verified our domain. So this has shown all the 4 naming servers which are running in Route 53 hosted zone. Okay, so now it's time to create our Kubernetes cluster. So let me clear the screen. It's a very big command. So Kops create and cluster. Now name of the cluster equal to cube vpro dot domain. Cube vpro is subdomain and main domain is imlaik.com. And state, where did we put the state? State is S3 bucket. Let's get into that and we'll copy that. Connect to EC2 instance and let me click on S3 bucket service. Let's bring it up. So yeah, I have this S3 bucket and let me click on this S3 bucket, and if you want to upload or download anything you can get it. And the properties and US West absolutely fine, and this is what we want. It's a vprofile S3 vprofile Kops state. Okay, let's copy this. Let me click on access point. Yeah, it's fine. The rest all it's okay. Yeah, state equal to, we are using S3 bucket and name of the bucket is this. I'll paste it here. Done. Then Jones US West. So I will go with US West. Okay, but before let me cross check what all that US West has. EC2 instance and global view. Yeah, we are in. Let me come down. US West, US West, US West, US East, US East. 1, 2, yeah, European Union, US West 2. Let me click on this. It has US West subgroups. So I'll use this Oregon. Yeah, here you should find zone name. You have US West 2A, 2B, 2C, 2D. Total we have 4. So I'm gonna use just US West 2A and 2B. That's more than enough. So US West 2A comma US West 2B. That's it. And after that node, then we have a node count. How many nodes you want to have, that you have to mention. So node count. So I'm gonna have node count of 2. I will create a 2. Okay, 2 nodes. Kops is our main node and remaining 2 nodes are our working nodes. Okay, 2 nodes. And size of the node size, that's a T3 medium. Our T3 small is also absolutely fine, but that's okay. T3 medium. Then DNS zone, this is very important. DNS zone, it's a DNS zone we have written. Let me copy that from here, or it's whatever from, yeah, this is S3 bucket. Yeah, this is our DNS zone, cube vpro imlight.com. Yeah, it's I'll paste it, DNS zone name, done. Then node volume size, what's the volume you want to provide for your working nodes? Node volume size equals to 8 GB. Then master volume size, it's a master for a master node, so master node volume size, I'm gonna give, how much would be better, just let me think. I think for master volume size it would be 8 would be fine. It's okay, 8 16 also okay, but 8 would also be okay. That's it. So now we have to enter and see what's gonna happen. So if you go through the output, it's been printing on the screen. Okay, finally configure your cluster with Kops update cluster name. Okay, so it's been the template has been created. Now we have to update this, and then we have to validate that. So once the validation is done, so we could see. So we have to update the cluster. So now you could see that the cluster configuration has been created. That means a template has been created. Now suggestions, list clusters with Kops get cluster. I did this cluster, that's okay. And then edit your node instance. And so now finally configure your cluster with Kops update cluster, and the name S and admin. Of course, we have to provide the S3 bucket also. That's very important. Without providing the node, without providing the S3 bucket information, you cannot store the state of the object. So that is the reason we have to provide. So now the template has been created. Now we need to update it, and then finally when we say validate, everything will be created. So now let's update the template. So Kops update cluster name option. So it's a Cube Wipro, it's on top. Let me copy this. And paste it here. Then after that, we have to attach the state, that is S3 bucket. State, we are using S3 bucket. And it's a V, where is that? Okay, I might have. Yeah, here it is. I copied some. Yeah, vprofile Charan cop state. Correct? Exactly. So let me paste it here. Done. And let us say yes and admin. And let's execute. So cluster is gonna start issuing new certificate etcd peer CA events. If you remember the etcd, we have discussed about the etcd and what it does. So now here you can see clearly on the screen what the etcd is doing. Okay, cluster is starting. Now it should be ready in a few minutes. So suggestions from Kops, validate cluster. So Kops validate cluster, wait 10 minutes. And list nodes, kubectl get nodes. If you use these commands, you can do this kind of task. That's what the suggestions are doing. So now it's we have to wait for 15, at least 10 to 15 minutes to for the setup to happen. Okay, after 10 to 15 minutes we're gonna do Kops validate the cluster. So then let's wait for few more minutes, and we'll get back to this. Yeah, now let's validate the cluster. So for that I am gonna say Kops validate and cluster state, again S3 bucket, sorry, S3 bucket, and the name of that is, I'll just copy it exactly, I don't want to make any mistake, so I'll just copy and paste it. Yeah, that's it. Let's execute and see what's gonna happen. So using cluster from kubectl context, that's a kubevpro.mlac.com, that's our route 53 hosted zone. So validating cluster kubevpro.mlac.com, and here you could see master node, US node, a master node, and a working node, and a working node. So all are of T3 medium, and US West 2A, 2A, 2B, all has been the node status master node, working node. One master node and two working nodes have been created successfully. Your cluster kubevpro.mlac.com is up and running. It's ready to serve you. So now let's validate and look at Kubernetes cluster from kubectl, and we'll see what's going to happen. But before that, let's mark these things. Okay, all done, absolutely all done. Now, so let's validate this Kubernetes cluster from kubectl using kubectl. So let's do ls, and we have these files because we are in a root home directory or root user home directory. So I am gonna say cat, and I will give the absolute path tilde / dot, and it's a kube, and then inside that you will find the config file. So this config file is very important. This is called a kube config file, a Kubernetes config file, and this consists of a lot of information, but for us a few parameters are very much important. So this is the file which is mainly for the kubectl, but this file is used by kubectl to connect to the cluster. If you want to connect to the cluster from external instances or external server, even from your local machine, still you can do it, but you need to have this config file in your local machine. So that's why this is very important. That's a config file of kube. Okay, let's look into that one more time. Yeah, it starts here, and here it's mentioning the clusters. Cluster, the first cluster, the certificate has been given certificate authority data. Inside that you can see that the name that we have mentioned, the kubevpro.mlac.com, absolutely this is ours. And the domain that we have used, if you remember, http, this is the complete URL of our server, and API, this is still that it's API, and after that kubevpro is subdomain, and mlac.com is our main domain. And contexts, we have a cluster with this name, and user with this name, and name also with that name, and here you can see the usernames. You can attach more users if you want. So client, here they have given the client certificate data. That's all about this kube config file for now. So we are going to delve into this kube config file later, but for now this is more than enough. Then this is mainly used to connect to the cluster, the kubectl. If kubectl should connect to the cluster, that is only possible through this. And now let's give one more command. So kubectl get nodes. This is the first ever command that we are giving in this course. Till now we haven't typed any kubectl commands, and first time ever we are typing our command. So we have to celebrate this moment. Cheers for you and me and all everybody who is following this course. Okay, I'm executing the first command in this kubectl get nodes. Cheers, guys. Yes, that's it. And this is the response. So total, how many nodes are running? 3 nodes. One is control plane, other one is node. These are two are working nodes, and this is a master node. This is a control plane. The cluster, we have created a cluster with one control plane and two working nodes, and age 7 minutes, 6 minutes, 6 minutes. Just recently we have created this. So now the next step, so we have done enough of validation inside our validations of kubectl config file, and then kubectl command. Now we will done. So now we will validate directly in AWS console. Validate the cluster in AWS console. Okay, so let's get into the AWS console, and Oregon, let me click on EC2 instances. Okay, it's dashboard. Let me scroll up. We are in EC2 instances only, and let me refresh it. Here is the magic. Here is the magic. Kops that we have created, and remaining 3. Let me make it. Yeah, fine. Node, master node. So master node is this, and working node these two. So all 3 instances have been successfully created by Kops. So big congratulations to everybody, whoever is following and whoever is able to do this till now or thus far. So one more thing you should able to see here. So let me get it back. Let me get back to that. Yeah, here, resources, auto scaling groups. Now you should see auto scaling groups also in addition to instances. What is this? So now this is created by auto scaling group. Whatever these 3 instances were created, those were created. It's not it's not magical. It's a proper systematically happen things. So that was done by auto scaling groups. So if you come to auto scaling groups, you should see 3 auto scaling groups. Absolutely, you see that? So one for master. Let me make it. Yeah, this is master US West 2A, and other 2 for working nodes are workers. Okay, that's how. And this one is created by the AWS itself. Okay, so auto scaling group. So this step is also done. Now let's look into an VPC which was created by Kops. So let me note down this. So these 2 were done. So next validation that we are gonna do is 8th one, that is looking into an VPC which was created by Kops. Let's get into that. So I will type VPC, a virtual private cloud. I have clicked it on. Yeah. So now I'll click on your VPC, and here it is. Our VPC, that's a kubeadm.com. So we have created a virtual private cloud, and here you can find all the information. DHCP option set you can find out here, and here you could find out CIDR. We have discussed about all this terminology in networking module. If you haven't watched it, kindly you go there and watch it and come back here, because you will get you will have a lot of fun there. So this is our CIDR. This is for IP version 6, and here you could see IP version 4 CIDR. We have clearly explained about this CIDR there. Kindly watch there. So main route table also you can see, and network ACL and all the information that we can see here. So now let's go to the route 53 zone, and we will validate that also. But let me mark this. So this is also done. Now validating route 53 zone. Yes, here you could see DNS management. You have one hosted zone. Let me click on that one hosted zone. Yes, it is. Here it is. That's kubeadm. This is our hosted zone, which is public. It's a route 53 record count 5. Let me click on kubeadm, and you could see the complete information about that. Of course, we have seen this before, but few more important things you might have seen on this. Those are all three. Let me make it bigger, and here it is. See, we got 3 more servers which are included in route 53. One is API kubeadm. So route 53 in your hosted zone, you will see new records that are created API kubeadm. In this points to the master node IP. So then you have an internal that points to the master node private IP. This is the internal, it points to the master node, whereas this one API which points to the master node, whereas internal which points to the master node private IP. Okay, API master node, this is also master node, but this points to the private IP. You can see that here. You can see that 172 private IP, and the top one is public IP. This is basically our API server. Inside one component, that's an API server. And here you could see the Kops controller. This is not important for us because this is out of basically cluster. This is what our cluster. This is private, and this api.kubeadm, this is a public one. So now enough of validations. Now let's delete cluster. Let me get back to our server. Let me clear the screen. Okay, gone. Clear the screen. Yeah. So now let's delete the cluster. So how can you delete that? I would say Kops help, and to delete, this is to update a cluster. This is to upgrade a Kubernetes cluster. Validate we have used. Version we have used. Export completion is here it is. Create a resource by command line, and this is to delete. Delete clusters, instance groups, instances, and secrets. Okay. So let's delete this. I'll say Kops and delete cluster, and name of the cluster equals to, we know that it's a kubeadm.domain, that's imlayak.com, and state S3 bucket. That's what it's storing the state of our objects or of clusters. So that's let me copy this directly. Yeah, here it is. Yep. So that's it. Now let me say S and done. Error reading cluster information cluster.kops.kh. Oh, that's it. So that's the that's the issue when you type names of the cluster or S3 bucket. See, I missed out a 0 over there, so it could not find that. So now it's gonna delete the cluster. It's deleting that. Not all resources deleted, waiting before reattempting a deletion. That's okay. Volumes, DHCP options, route tables, subnets, completely virtual private cloud is going to be wiped off. An internet gateway, and let's wait for a few more minutes. Volumes are getting deleted. That's okay. So it's going to delete all of them, and it takes some time. Once the cluster is once the cluster is deleted, it's going to give it's going to give us back our shell. And never ever, do not try to delete this cluster manually, like when we were kids, when we were watching WWE. So that time they used to say, do not try this. So I am also saying, do not try to delete this cluster manually, because there are a lot of things are there. So if you really want to do it manually, then you have to start from auto scaling groups. First you have to delete auto scaling group, then you have to delete one by one all the services that we have used. Okay, that's it. Deleted kubectl config for kubevipromlac.com. This is our cluster name. So the cluster has been deleted successfully. Now let's rerun the cluster. I'm just playing around. Okay, now let's rerun the cluster. So to rerun the cluster, now if we want to create it once again, it's just two commands. Just two commands. So but most important aspect is the most important thing is, you should not remove your prerequisites. That means I'll show you that all those things should not be removed at all, like S3 bucket, IAM user, route 53 hosted zone. These things you should not touch it. If they're intact, that means you can recreate our cluster with two commands. Okay, the first command is Kops. Let's give the command directly, or I'll just volume is 8 and master volume is 8. Absolutely fine. Let me create this. Now the template is going to be created. Then we have to update the changes. We have to update it and we have to validate it. So that's it. Okay, error reading. What's the issue? Okay, S3 bucket, na? The issue is with S3 bucket. Okay, let me copy that. Let me check the S3 bucket. Okay, Kops, maybe cop, some spelling mistake. vprofile cop states. Okay, I got it. The issue is here. Yeah. Anyway, I'll just paste it. State again, that's also one more issue. Yep. That's it. CIDR. Let's wait for that. Finally, configure your cluster with Kops update cluster. So let's update that. Kops update cluster and name. It's a cube vpro dot imlac Okay, we'll keep this one and we will do the changes till state will it remains same. Then adds a yes and admin, so rest all fine. So this is also okay. So here I'm gonna say Kops update. Yeah, so the template is being updated, and finally we to validate, then our cluster will be up and running. But before, yeah, so that's it. The cluster, it should be, the cluster is starting now. The cluster is starting now. After a few minutes it should be ready, so we have to say validate. So validate is nothing but we are just cross checking whether the cluster is started or not. So first one, when we say Kops create, it will just create a template. It will make sure everything is done, all are available. And once we say Kops update, then it's gonna create, it's gonna do actual action, it's gonna create those things. And when we say validate, and it's all done, it's cross checking, it's validation. So now let me say Kops validate and cluster, and here name is not required. Let me give the state, that's S3. vprofile Charan and Kops state. That's it. Let's see. I think it will take some time. Okay. Okay, it's taking some time. Let's wait. Cluster not at healthy. We have to wait for a few more seconds, a few more minutes maybe. That's it. Our cluster cube wipro.imlight.com is up and running. Let's validate it one more time. So EC2 instance, and here it is. We are in Tokyo. Let's go to the Oregon. That's US West 2, and you should see instances running, and we will go for all instances all. That's it. See, 3 instances were terminated because we have deleted the cluster. So those initial 3 were terminated, and now again master and then working notes again has been started back, and you can see the complete information about that. Okay, I think it's pretty clear for you. So we have seen enough. Now what we're gonna do is, if you want to if you want to continue with this with the next tutorial, you can simply leave this cluster up and running, or else you can delete this, cluster saying cube saying Kops delete command. Okay, but I hope you will follow me for the next session. So keep that cluster up and running. We will see you in another tutorial, that too specifically on Kubernetes objects and config files. Now the cluster has been successfully created. Now it's time to deploy and scale up our applications. So let's begin with our first exercise, and the name of this exercise is stateless application. It's a stateless application, and the application name is Hello-kubernetes. and we are going to do deployment and expose this application to the external world using a load balancer. Okay, so here when I say deployment, I do not mean a deployment object. Okay, this when I say deployment in my slides in here, it doesn't mean a deployment object. It's a regular deployment that we do. So we are going to deploy an application and we will expose that to the load balancer. That's what the activity. So let's write the objective of this, and so objective main thing, we will run 5 instances of a hello world application, and we will create a service object that exposes an external IP address, and we will use this service object to access the running application. That's it. Use the service object to access the running application. Okay, so now let me put it in a proper way, in a Kubernetes way. First, what we are going to do is run 5 instances of a hello world application. So if we want to run 5 instances or 5 pods, that means this is a replica set object. A replica set object. Then we want to create a service object that exposes an external IP address. To do that, we need to go with the service object. A service object, we have 3 types of service objects, 3 types of services. One is node port, second one is cluster IP, and third one is load balancer. Okay, and the fourth one, using this service object, we should access the running application through the browser. That's what the fourth one is not the Kubernetes object, it's just a activity or activity. Okay, now if you think a replica set, so when we create a replica set, we are going to create pods also. That is the outcome of replica set. So here pod object, 5 pod objects will also be created. But do we use replica set to create or direct pod object? Which one we will use, which definition file we will use, that we will see. But for now, what I'm going to tell is, so to make this process simple, so objects, so definition files that we are using is one, deployment definition file, deployment object definition file. So when we use a deployment object definition file, in that definition file we have written in such a way that it's gonna create a replica object with pod objects, 5 pod objects. That's it. We'll get 5 pod objects. That's the power of deployment object also, because if you want to do this activity, how can you do that? You have to first create a pod or replica, whatever you want, then you can go for the other. But you have to face some issues if you want to update, if you want to roll back, if you want to do some changes. That's not possible with the replica set object. So that's the reason what I'm doing is I'm using a deployment object definition file, and then inside that I'm mentioning replica set information and pod information. So once it is done, our pods will be up and running. Now it's pretty simple. So now we have to create a service object. And what type of service object? From definition file. But what kind of service object we want? We will go with load balancer for this example. But here what I am doing is, this service object I am creating not from definition file, not a declarative way, service object through imperative way, from the command, okay, or from the command. That's it. Now it's time to jump into the action or swing into the action. Okay, let me clear the screen. Okay, sudo option I, clear the screen. Now let me get into the root user home directory, and then defs directory and ls. So here I will create a folder called mkdir. So I am gonna create as kops. So cd kops ls. Now let's create one more directory saying mkdir, name is Hello-kubernetes, Hello-kube. So now let me enter into the Hello-kube and do ls. Oh, nothing there. So now it's time to write our definition file. So the first step in this is to run a hello world application in our cluster, in our Kops cluster. So let me take this. So the first step here is, so there's a steps now, steps that we're going to execute. The first one is to create a deployment definition file and create deployment object. Okay, let's do this first. pwd, yeah, fine. We are inside the Hello-kube. Now let's write the name of that. So it's vim and load, and this is I'll name it as vim hello kube dot aml. So let's write our load balancer definition file. So what will we do? We'll do the same. We will get into our VS Code and we will write it there and we'll copy paste it here. So now let me get into that Kops directory. Inside that I will create a folder called Hello-kube, and inside this I'm gonna open my VS Code. Okay, so let me close this, click on new file. The name I'm gonna give is load, this one is Hello-kube dot Hello-kube def dot, it's Hello-kube deployment definition file. So that's why I'll say Hello-kube dep aml file. Okay, let's begin writing our deployment object definition file. So let me say kind and get the template of deployment object. Yeah, I got it. Now let me remove this. Yeah, IPA version apps v1 kind is deployment. Metadata name I'm gonna give as Hello-kube, and labels I'm gonna attach labels. So I would say app, yeah, for app, and I would say hello cube app. Cube app would be better. Yeah, done. So now spec. Let's come to the spec. In spec, how many we have replicas first. Let me look into the replicas. So here I do not have the replicas. So first let me put the replicas here inside the spec. I want a replicas. I want 5 replicas because I'm using a replica set object here. So replicas 5. Then after that I have selector basically to match with other object. So here I'm gonna mention in match labels app, and then I'd say match labels app, and the name of that app is cube app. Done. Then after that we have template. In template we have to provide the metadata, and metadata label is again app. It's a cube app. Done. So now it's time to attach the image, attach the information about the container inside the spec. So name of the container I'm gonna give is Hello Cube, and image I'm gonna get it from GCR, that's Google Container Registry, gcr.io / Google samples / node hello. So node hello, and tag is 1.4 that I'm gonna use it. And once the image has been given, now it's time to map the ports. So I do not require these resources. I'm gonna remove this. Yeah, yes, port is in same indentation as image, absolutely fine. So the container port I'm gonna go with 8080, and after this, at this port I'm gonna attach our load balancer. Okay, let me cross check one more time. API version is fine, and kind, it's a deployment object definition file. Metadata, I put hello cube inside the label app cube app, and in spec replicas in selector I have matched these labels with the top label match labels, and then template I gave the same app, and then container, let me cross check this image GCR IO Google samples node hello tag 1.4, absolutely fine. Let me copy this first and get into our Kops machine. Kops and ls vim hello cube, and what's this, let me say I remove all those things information, or else let me say percentage d modifiable is off. So rm rf, so vim hello cube dot ml, and paste the respective code of object file. So let me do wq save and quit, and let me do ls, and here is our definition file, a deployment definition file, which gonna create this when this deployment definition file can create 2 objects in turn. One is 3 objects. One is deployment object, and then a replica set object, and finally it will create a pod object. How many pod objects? 5. Let's look into that. So let's apply the changes. So let's create the object. So kubectl, then apply or create. Apply is advanced command, and then file name is hello-kube.aml. That's it. Deployment.apps and Hello-kube has been created. If you think only one object will be created, that is foolishness. So what I'm gonna do is I'll say kubectl and get all, and you should see all. We got a service. This is existing one. This is not belongs to us. You created a deployment dot apps. It's a Hello-kube deployment object, and you have created a replica set dot apps, and here you should see Hello-kube replica set object. So now kubectl get pod, and here you should see all the pods, 5 pods which are up and running, because we have gone with the replica set of what replicas. How many we gave? I'll show you. So we gave 5. So that's the reason 5 pods has been created. So with one deployment definition file, we have created a deployment object which is Hello-kube. We have created a replica set object which is Hello-kube with random number, and then we have created 5 pod objects. Now let's get into the deployment object. So let me say kubectl get deploy. So this is our deployment object. 5 ready, 5 update, 5 available. Okay. So up to date, 5 are up to date, and 5 is available. Current state to desired state. Everything is satisfied just 95 seconds ago. Even our pods were created just 47 seconds ago. Now let me clear the screen and say, this time what I'm going to say is kubectl get all. So this is what I want to prove. So with one deployment object definition file, you have created an object, you have created a pod object, you have created a deployment object, and you have created a replica set object. So that's the power of deployment definition file. Of course, you can do more than that. You can do a lot of activities, such as you can update, you can change, you can roll back, so roll out, a lot of things you can do. That's the other benefits of deployment. Okay, so let me also do kubectl describe and what we have here is deployment. I want to describe deployment, and name of the deployment is Hello-kube, and this is the information about the deployment. So normal scaling replica set, it took age is 3 minutes 2 seconds, and deployment controller has come into the action. So here you should see the information about the replica sets. We haven't done any rollouts, so that's the reason we have only one replica set. That's a new replica set. Old replica set is not there at all. Then we have image, the image that we have used, and port mapping is here, and mounts we haven't used, and here you have the more information about that. Labels, you see that the label that we have used is app equals to kubeapp. Annotations, selector, again app is equals to kubeapp. Replicas 5 desired, we have asked for the 5, and 5 updated, and 5 total we have 5 are available at this moment. That's enough. So rolling update strategy, 25% is maximum unavailable, 25% is maximum surge. At any time 25% can only be unavailable. That's the rolling update strategy when you are doing rolling updates. Okay, at any remaining 75% is always available when you are doing rolling updates, from changing from new to old. from new update to old update, 25 while changing 25% will only be unavailable, rest all will be available. Okay. For example, you have 100 pods. When you are rolling out to the new pods with the new update, then what's going to happen is, while you are changing, it may take 5 to 10 minutes or 15 minutes, sometimes it may take 20 minutes. While changing, only initially 25% will be changed, remaining 75 pods will be up and running. And after that, at any time while rolling out, at least 75% will be available, 75% spots will be available, so that your app will up always. Okay, so now it's time to, so enough of deployment. We have seen the deployment, we have described the deployment. Now after that, we will also see kubectl get rs replica sets. You see that this is our replica set. We have desired for 5, and current we have 5 and ready 5. Then if you want to describe it, you can describe this also, kubectl describe, and it is a replica set. I will say rs, and name is too much. I'm gonna copy it. And here it is. So normal success total 5 na. So 5 pods were created using this replica set, and you can see the each and every pod name. And image rest all remains same. It's not completely different. So now I'm gonna say kubectl get pod, and you should see the same exactly these 5 pods and these 5 pods. Okay, and if you want to see each and every pod, you can also describe the pod. That's not a big deal. But what we're gonna do is, we have to create a service object. Okay, the first step in this is done. That's create a deployment definition file and execute it. Okay, and create a deployment object. So while we have created this deployment object, how many objects were created? How many objects were created? 1. It is pod. 5 pods were created. 2. A replica set object was created. 3. A deployment object was created. That's it. Now the second step is to create a service object that exposes the deployment to the outside network. Imperatively, I will use imperative method. So imperative method for now. Okay, let's do that now. So what I'm going to do is, as it's imperative method, so I will say kubectl. For that, I have to say expose. What do you want to expose? I want to expose a deployment. And name of the deployment is Hello-kube. And what type of service you want to have? We have 3 types: node port, load balancer, and cluster IP. I'm going to go with load balancer. It's an environment variable. You have to make sure you have given correctly. Capital L load, and after that capital B balancer. Okay, it's fine. Rest all fine. So now I have to give few more options. Name. So what name you want to provide this? I'm gonna say this is I'm gonna say it's kube service. Okay, kube service. Let me click enter. That's it. Your service or kube service has been exposed. Now let's see services. So to see the services, to display information about the service, you have to say kubectl get svc. Okay, you have two services. One is cluster IP type service, which is default one. You don't need to touch it. And the other one is the service that we have created. It's a kube service, and the type is load balancer, and cluster IP is this, and external IP, it's still waiting for something. Let's see. So now what will we do is, let's get into our AWS, and we will see whether any cluster, any load balancer has been created or not. So now let me come here, Amazon Web Services. Yeah, let me refresh it. Yeah, this one. That's it. It's been created. So load balancer is started. It's been put into action. So let me click here for more information. So now we are inside the load balancer dashboard. So zero, the health checkup is still taking place. Once health checkup is done, it's gonna start two instances. You could see the status zero of zero instances in service. So it hasn't been started. So now let me get into the instances. Okay, it has selected two availability zones: US West 2B, US West 2A, and subnet IDs, and but it hasn't started any instance. It's doing health check. So let's look into the health check. This is the information. Ping target is this, and timeout. So listeners, so this is gonna the load balancer port. This is 8080 is load balancer port. This will be listening to the instance port at 30,088. So this here we'll get the monitoring information, and let's wait for that. And tags. So we have default kube service at this, and Kubernetes cluster we are using kubevpro.mlac.com, and it's owned by this guy. Okay. So let's, and final one is migration. It's not required. Let me get back to the description and let me see the status. Nothing. And here also you can see the port configuration. 8080 TCP. To forwarding this, our load balancer will forward the request to 30,088 TCP. So at this port, whichever pod are listening to that port, that will be accessed, and inside that pod, the container will also be accessed. So let me refresh it. Okay, one of two instances in service. Let me get here. So one is in service, which is this one, and you can see that nodes US West 2A kubevpro.imlag.com. Other one is out of service. It will take some time. I'll show that instances so that you'll get more clarity that these were created in our instances only. You see that nodes. Okay, so these are the two. You see that these are the two nodes, US West 2A and US West 2B kubevpro.imlag.com. Correct? These are the two instances which are part of our Kubernetes cluster. These are the two nodes which are part of our Kubernetes cluster, and here you could see in that two nodes, two instances has been created. So let me refresh it. Okay, so now two of two instances in service, they are up and running, no issue at all. You can see that two instances are in service. So now it's time to get back to our Kops machine, and let me give kubectl get svc, and here it is. You see that before it was pending external IP. Now you could see the external IP here. Okay, and this is our external IP, and this is the port mapping 8080 with 30,088 internal. So this is where this is the IP we have to get it, and this is the port we have to take, but not from here. I will take from the Amazon Web Services only. Just you can come here to the load balancer. You see that DNS name. You click on this icon, copy icon, and let's paste it here, and 8080. That's it. Let me zoom it. Hello Kubernetes. That's it. Deployment, a proper way of deployment and exposing this to the outside network using the Kubernetes object, proper Kubernetes objects. Let me show you. Let me mark this also. So this is also done. And then the third one, validation, is also done. So here we have used service object. So pod object, replica set object, deployment object, service object. These are the main objects of Kubernetes. We have used all to deploy a simple Kubernetes, Hello-kubernetes application. So before we look into the other aspects, I just want to tell you one more thing. Many of the people may face some issues when dealing with your load balancer. Sometimes your load balancer may not come up even for the long time. In that case, the problem could be, see, this is the elastic load balancing uh, user guide. So you can go through this. The problem could be you might not have this AWS service role for elastic load balancing. If you do not have this elastic load balancing, what you can do is, by when you create, by default it should be created by the AWS. If it is not, then you have to create that. So or else you manually create one load balancer in your AWS account. If you manually create a load balancer, one load balancer, then obviously this AWS service role for elastic load balancing will be created. Then after that, when you want to create it from the Kops, from the Kubernetes cluster, it will work. Okay, so you can see that you don't need to manually create the AWS service role for elastic load balancing role. Elastic load balancing creates this role for you when you create a load balancer or a target group. Okay, so I will show you my, you see that Amazon service role for elastic load balancing. This is what you require to have. So let me refresh it. Yeah. See, I have some roles. I have attached some roles. By default, I have attached this also, like EC2 role, AWS service EC2 role using kubevipro, masters and nodes. And then this is by default, it will be attached. In addition to that, you could see that service linked role, service linked role, service linked role. So this service linked roles will be attached when you try to create your load balancer or respective service. If it doesn't happen, you manually create one load balancer or one service, or else you can manually create that service itself. So here you can see that this is what I'm talking about, AWS service role for elastic load balancing. Okay, so or else you can click on create role, say AWS service, and then here I have used this EC2 instance. I have used this EC2 also. You want specifically for what do you want? Elastic load balancing. Here it is. You just click elastic load balancing, you check mark this, and then click next, and then yes, you will get it, this AWS elastic load balancing, and then you click on next again. So here it's saying allow it ELB, elastic load balancing, sorry, allows elastic load balancer to call AWS services on behalf of you. Absolutely, that's what I want. Either you can copy this exactly and go to the, let me come here, and let me open this on a new tab, and once your cloud shell is up and running, you just paste this. So once it's running, you take that and you paste it and you execute that. So that also works. So after that, once you have selected that, you can click on create a role. So a role with this name already exists. That's why I cannot create it again. But that's how you can create. If you get that problem, most of the people will face this issue. So that's the reason I'm specifically mentioning, I'm specifically explaining how to solve that problem. Okay, so now let's get back into our exercise. Okay, so now what I'm gonna do is so we are successfully accessing this. You can see that. I'll refresh it. Yes, still it's up and running. So now let's look into that cubes. Okay, sudo option I a yeah. Okay, so now let me say kubectl get services and hello. What's the name of our service? Hello-kube. Okay, kubectl get svc, the name of our kube service, sorry. So kube service, so we want to get only our service. Let me say kubectl get svc hello, sorry, kube service. It's on top, kube service. Yeah, you see that this is only our service, kube service, load balancer and external IP and port mapping and 12 minutes ago. That's it. So type load balancer service is backed by external cloud provider, that is our AWS, Amazon Web Services. Now let's display detailed information about the service. So what I'm going to do is kubectl describe, and it is services or svc, and name of our service is kube, sorry, kube service. Okay, initially we face some issue, it's unable to connect with our load balancer. This kind of error you may also get it. You see that, you see that the problem here, service controller error syncing load balancer, failed to ensure load balancer, unable to update load balancer attributes during the attribute sync, access denied. So if you get this kind of error, because no identity policy allows the elastic load balancing, you see that this part, elastic load balancing on. So if you face this kind of issue, then you follow that, you do that. Okay, then you can see that load balancer is normal. So 10 minutes ago, service controller and ensuring load balancer, absolutely fine, no issue at all, it's working well. Let me scroll up, and here you could see complete endpoint, a complete endpoint. So we have two more endpoints, however, because these are all connected through the Amazon Web Services load balancer. You can see name of the service kube service, namespace is default by, and then labels, and type is load balancer, a single stack family IP, and load balancer ingress is here. So this is our load balancer ingress. Directly you can copy this and use this to basically access our application, and 8080, that's the port, and target port is this, and node port is this 30,088. By default it will take, we don't need to give it specifically, and endpoints and external traffic cluster. That's it, that's all about this exercise. So now what we're gonna do is we will delete the respective, will clean up, we'll clean up. Okay, but before we clean up, I'm gonna get into the pods. We'll see the pod. Get kubectl get pods, or, and I want a wide information, a more information output, equals to wide. That's the option I have used. And here are all the pods. All 5 pods are up and running. So what I will do, just to have some fun, I'm gonna delete a few pods first. Okay, I'm gonna delete few pods and we'll see what's gonna happen. You can see that all 5 pods are on top. I will delete these 2 pods. So kubectl delete pod, and I'll give the name of the pod. This is 1. Paste it, and this is 2. We will delete 2 pods and give a space and paste it here, and let me execute it. See, 2 pods has been deleted. kubectl get pod, but still 5 pods are running. So these 2 are terminating, still under terminating status. 25 minutes, 25 minutes. In space, in spite of those two, in place of those two more pods are started. One is 16 seconds, other one is also 16 seconds. You see that? 16 seconds, 16 seconds, and remaining all are 25. That's the power of replica. Basically, how we are able to achieve this? Using a deployment definition file, using a deployment object. So we have to thank deployment object for that. Okay, so after thanking the deployment object, we will do one more activity, that is we want to use the external IP address, the load balancer ingress, and to see, because we have taken this load balancer ingress from AWS and we have seen in describing the service, but there is a one more way to get it. That is, you can say curl and so now it's time to clean up our Kops machine. So let's delete the service and we'll begin with the service. We will delete the service first. To delete the service, we have to say kubectl. Okay, what the issue? Let me clear the screen. Kubectl and delete services, and name of the service is kube service. So the service has been deleted. So the service has been deleted. Still kubectl get pod, sorry, not get pod, get all objects. You have okay, the service hasn't been deleted. It will take a few more minutes. Let's wait for that. Yeah, now it's been deleted. You see that here? No service, only cluster IP service is there. I'll show it. Yeah, so now the pods are still there. Pods are up and running, and you have services which is cluster IP. This is default one. Our service has been deleted, and deployment object is still there, Hello-kube, and replica set is still there. So we have a pod object, we have a deployment object, we have replica set object, we do not have a service object. Can we access this application? Yeah, I'm asking you only. Can we access this application without service? Let's see that. So this is our application. I will refresh it. That's it. Gone. That's what happens. Service is very important. Without service, you can't do anything. So that's why. So with this, you should able to get. You should understand that a service is the one which makes your application to expose to the outside network. If that is not there, you cannot do anything. So each object is very important. So as we do not have a service, we can't basically expose it to the external outside network. So now we will delete all other objects also. We will begin with first we will delete replica, or we'll just delete the deployment. Rest all will fall in place. So kubectl delete, this is deployment, then name of this is Hello-kube. Okay, that's it. Deployment.apps Hello-kube is deleted. Now let me take few seconds to look into other objects whether they got deleted or not. Okay, let's wait for some time because it may take some time. Let me say kubectl get all. Okay, these are getting terminated, and your service, okay, your replica set is gone, and these are getting terminated. Let's wait for a few more seconds and execute the same. Let me clear the screen and let me say kubectl get all. That's it, all gone. The default service is left, and then job that I have created 44 hours before is left. Rest all deleted because we have deleted the deployment object, and replica set and pods are dependent on a replica set, and replica set is dependent on deployment in this definition file. So that's why with removal of deployment object, all got deleted. So with this, we have successfully demonstrated the objectives that we have discussed earlier, that is running 5 instances of a hello world application using replica set object and then pod object, and then we have created a service object that exposes an external IP address using service object, and we have used the service object to access the running application, and we have accessed it through our browser. Now it's time to say goodbye to this exercise, and we will meet in another exercise. Now it's time to see a complex application. So now in this tutorial, I will show you how to build and deploy a simple, but this is not the production ready, a multi-tier web application. A multi-tier web application using Kubernetes and Docker images. So this tutorial consists of two things, mainly PHP and a single instance redis to store guestbook entries, a redis database, and PHP, a simple PHP front end. So these are the components. Let me write down. Let me check the sticky note. Yeah, here this is exercise 4 in this. That is PHP guestbook and web stack. One is PHP front end, and second one is redis single instance database, mainly single instance database, but we'll take some followers. That's it. And what is the objective? So here what we are gonna do is we will start up a redis leader, start up to redis followers, and third start up the guest book front end, and fourth expose and view the front end service, and fifth, cleanup. That's it. These are the objective. So these are the tasks that we are going to do in this. So before we begin the action, let's look into the PHP guestbook and Kops Kubernetes cluster architecture all put together. Here is that, the complete architecture. So let's begin with, as usual, let's begin with our creation of our cluster. So that has been done in our previous tutorial itself. If you did not watch that, kindly watch that tutorial, that Hello-kube tutorial. In that we have shown how to create our Kubernetes cluster using Kops with 3 instances. Basically this cluster consists of a master node, that's here, and a working node, that's here, and another working node, that is here. So total 3 machines. I will show that cluster also first. Yeah, let me go to the EC2 dashboard. Instances running. This is Kops machine through which I operate, and this is my cluster. These 3 are my cluster. You see the name master US West 2A and node US West 2A, node US West 2B, and these are the 3 instances of AWS are part of my Kubernetes cluster. You see master US West 2A master. This is master node, and these are 2 working nodes, and these 2 are part of my cluster, which are basically 3 instances in EC2 instances in Amazon Web Services. I hope this is clear. So now what we do, what all activities we do in this. So in this we will begin with starting up a database redis deployment. So we have a redis leader. You see that we call this as a redis leader. We will first deploy this pod. We are not creating pod alone, we are creating deployment object. When you do that deployment object, it will create a pod as well as replica set. If you want, that also can be made. So first thing we are gonna do is we'll create the redis deployment. Let me write that activities here on this side. Yeah, this is fine. So steps. Step 1, we will create the redis deployment object. Okay, we'll write and create the redis deployment. Then we have step 2. So once this is done, so our redis database pod, this is the pod. Inside that you have a container, so it's been deployed. So now what's next? The next thing is to create the redis service, create the redis. We call this one as a leader. The first one we have created, that's a leader. Okay, redis leader, redis, we'll say that leader. Okay, redis leader deployment. Then after that we will create a service for this. Create the redis leader service. We'll write a service file, a service definition file, and we will create a redis LSVC for this. Okay, then once that is done, then the third step is to create a deployment definition for redis followers. This is redis followers. What is redis followers? I am going to explain, but for now it's two more additional pods we are going to deploy, and let me write that. And step 3, create, basically you can say setup, simply set up the redis followers. You will do the same. Inside that we will do the same. One is deployment, pod is done, and in addition to that, service also. So create the redis follower service, both. Okay. So then, so far, one redis leader pod and a redis service is done, and after that we have created a redis follower deployment. In redis follower deployment, it's gonna bring two pods with one replica set. Basically, this is a we use a replica set object. We'll mention two replicas, so then obviously we'll get the two pods. Okay. Then the next step is to, it's time for our front end deployment. So then we will deploy front end. We will create a front end deployment. When you create a front end deployment, we'll create two objects again. One is a pod object. So, and how many pods that will be created is again depends upon the replica set that we have mentioned. So we are mentioning 3, so we'll get the 3 pods of front end. So let me write that. Next, step 4, write and create front end deployment. So once it's done, it's time to write and create a front end service. And this here I will do both. One is cluster IP, second one is load balancer. So both I'm gonna do. Okay, so that's the 5th step. So 5th step is to create a front end service for all 3. Then this front end service I am gonna make it as a load balancer. So this load balancer, for this I will use Amazon Web Services. I will use the Amazon Elastic Load Balancing Service to do that. Then once I create Amazon Elastic Load Balancing Service from this cluster, I will access I'm able to access this front end from the Amazon Web Services Elastic Load Balancing endpoint. Once you copy this Elastic Load Balancing endpoint and paste it into your browser, you should be able to access your front end. And obviously this front end is connected to back end. So all together they have connected. So that's how the overall architecture looks like, with pods, with containers, with services, with deployments. Everything I have shown it to you visually, pictorially. I hope you really like it. So now let me attach those things also. So the step 6 is to get into the AWS ELB and copy the endpoint and paste it into the browser and access the front end of the application, front end of the guest book. Okay, let's do that. I hope architecture is pretty clear. Just look into the architecture. I will give you 10 to 15 seconds. Just look into the architecture. If you get any doubt, please rewatch the video. Rewatch the video and follow me in the coming forth section. Okay. Okay. I hope it's fine. It's fine. So let me get into the instance directly. This is our Kops machine. From here, normally I manage my cluster. So I call this as a Kops server, and I will manage my Kubernetes cluster from here. So let's do this and clear the screen. So this is a redis. We will begin the action. Let me get into the and here I'm going to create make dir. This is PHP guestbook. PHP guestbook. Yeah. Now let me enter into that PHP guest. Okay. So now let's begin the action as usual. Let me show that sticky note. Our first step is to write and create a redis leader deployment. Okay. It's about the database. Let's write that. First definition file. So let's create the file. It's the name I'm gonna give is redis and l tep.ml. We'll keep it like this. We will create this file in our VS Code and we will copy that code from there and we'll paste it here. So this is my directory. So here I'm going to open my VS Code and here I'm going to create that file. So I'll say redis leader for that L and dep.ml. So let's begin. So kind deployment type. Okay, got it. Let me remove this which is not required. Rest all fine. Metadata, let's begin with the metadata. So here metadata name I'm gonna say redis and just L. That's it. That's the name of the deployment object. Then after that labels, I'll directly attach a labels here in this. So labels, yeah, in labels I'll have the first label as a app and redis. Then I will have a role is leader. Then I'll have a tire. So this one I'll say backend. So then after that I will directly go to the spec. Inside the spec I will attach the replica set. This is a replicas object. So how many? I will go with only one. Okay. And after that I have a selector. Inside that I will go with the match labels. In the match labels I want to match this with my labels. So I have this as a redis. I will write it as a redis. Done. So then I have template. So inside the template I have metadata. Inside that metadata I have labels. I will use the complete a similar label as it is. So I'll copy this and I'll paste it here from here to here. Okay. So let me bring it to the same level of indentation to this. Yeah, done. So then we have a spec. Here we need to mention about the containers. So I'm going to attach about the containers. So the name of the container I'm going to give is just a redis leader. That's not an issue. Redis L. That's the name of the container or just leader I'll say. Whichever is fine. Then image it's dockered. So I'll say docker.io and then redis tag is 6.0.5. Okay, done. So let's keep the resources similar. Requests and resources I'll put requests not limits. This I'm going to change it to requests. I'll attach one more. It says requests. Yeah, got it. and inside the request I will attach a CPU 100 mega. Then I will attach memory. This is 100 mi, capital mi. Got it? Either way, that's fine. So now I'm gonna remove this limits. It's not required anymore. Yeah. So now let's come to the ports. Container port, I'm gonna go with 6379. Rest all fine. 6379. That's it. Absolutely fine. Let me cross check this quickly. Metadata is okay. Then spec is okay. Then template is fine. And spec, that's a container image, is also fine. And then resources we have provided. Container port is absolutely fine. Let me Control C to copy everything. Let's get into our server. Now we will create this file. Okay, let's do that. So nothing is there, but still. So vim, let's create the file. It's redis l and dep and .ml, and let me paste it here, everything, and save and quick as possible. Save and quit. Done. So our file has been created, definition file has been created. Now it's time to create or apply this redis deployment definition file and create our deployment object. When we create our deployment object, replica set object will be created, as well as pod object will also be created. Let's see that. So for that, what I'm going to do is kubectl. I'll use apply and option F, and directly I will name it. So that's it. It's successfully created. It's been successfully created. Now let's check what all objects also has been created. But before we check, let's wait for some moment. Before we check all, let's only check the deployments. kubectl get deploy, because it will take some time to pod to come into the action. Okay, it will take some time for replica set to come into action. So that's the reason. Let's wait for few minutes, and before that, let's cross check the deployment. Okay, our redis l, this is the name. This is the name I have given. So redis l deployment is ready. So one by one, it's up to date, available one. Just 30 seconds ago, it's been created. Now let's try to look into all other objects that were created when you create a deployment object. So for that, I'll say kubectl get all. That's it. So you could see that this is your, forget about this. This is a default service. You don't take this one. You don't consider this. We have created this a deployment object 58 seconds ago. At the same time, replica set object with the name redis l. This is the deployment name, and this is computer generated name is attached. The string has been attached to this, and then a replica set object has been created. One desired, we have mentioned only one. So one desired, one current, one ready. So I'm waiting for pod to be created. So I will give one more time all. Yes, this time pod is also up. You see that? Pod. So pod object, just 10 seconds ago, pod object has been created, and deployment object, and then replica set. So with creation of one object from deployment definition files, all three objects has been created. Okay, so now let's query the list of pods to verify that the redis pod is running. So kubectl get pod, and that's it. Redis L pod is up and running. I'll show you the picture also. So far what we have done is just this. We have created a Redis leader, pod, and the container, and deployment and replica set objects. Okay, now let's get back to the. So the first step in this is done. Step 1, okay, now step 2 is to create the step 2 is to create the redis leader service. Now its second step is to create the redis leader service. That's what now you see that, to create a redis leader service. Let me do that. So again we have to write one more file this time. So the guestbook application needs to communicate to the redis to write its data. You need to apply a service to proxy the traffic to the redis pod. So that's why redis pod is pretty much important. A service defines a policy to access the pods. Then why do you require a service? Because we have two application or two separate services. One is front end, which is written on PHP. This is Redis, which is a database. Now until unless this front end communicates with the Redis, you cannot store the data that has been typed into the front end. So that's the reason we have to make this communication possible between this front end pod and then a redis pod. For that what we require, literally we require a service, because the kubernetes service object only can do communication possible. So that's what we are going to do. So let's get into that, and let's write a service object definition file. So the name I'm going to give is redis-l service svc.aml. okay, before I give the name, let me create that in here and let me go there. So redis l and svc dot aml, and kind it is service. Yes, got it. Yeah, so kind is service metadata. So the name metadata I'm gonna give is again similar, redis l for this. Yeah, spec. So labels I will attach similar labels. I'll just copy paste it from here. So tip. So these three labels I'll use the same labels. After the name, so I'll attach the labels section. So here I'll paste it. Okay, so let me bring other two to the same level of indentation of app. Okay, now it's fine. So labels is also given. Now it's time to attach the spec. So inside the spec we will attach the port selector information first. So selector information, again you need to give the similar one, the same three. Okay, yeah, so let me bring it to the same indentation level. That's it, all fine. But only thing, okay, redis leader backend, redis leader backend, absolutely fine. Now it's time for the port and target port, because it's a service, and this is this one we are using is a node port. Okay, so 6379. So this is the port. And target port, whom should it target? Whom should this database target? this database should connect to the another container at target port. Okay, what's that target port? That is 6379. That's it. Rest all fine. Let me save this file. Okay, I hope everything else is fine. No issue. Ports, spec. Yeah, I hope it's fine. Let me save. Okay, so it's a wrong one. Yeah, sorry. Okay. Let me create a file here, vim, and it is redis l and svc.ml, and insert mode, paste it, wq, save and quit, and it's time to create a first service for the database, redis database. So what I'm going to say, same command, kubectl apply option F, and then it is redis l svc. That's it. Your service has been created. Let's query the list of services to verify that the redis service is running or not. So what I'm going to do is kubectl get svc, and here it is, redis l. That's what the name we have given, if you remember, and it is a cluster IP type service, and then it's up and running. The target port is 6379. So whatever is running at this port, that it will connect with that port. Okay, so our service has been created. So with this we have reached to this level. Okay, and we have completed the second step also. So what's next? Next is to create a redis follower pod, or literally a redis follower deployment, and then a redis follower service. That's the next step. So let's get into the action again. So now let's set up the redis followers. Although the redis leader is a single pod, you can make it highly available and meet traffic demands by adding a few redis followers or replicas. Now you got it why I am creating this redis followers, though I have a redis leader. So I want to meet the traffic demands. If traffic is too much, automatically these redis followers takes up the load and it supports our application. So that is the power of Kubernetes. So the future is all lies with the Kubernetes. Okay, so now let's do that. Let's create our redis follower deployment file. So for that I'll go to this and I'll write as redis follower f and deployment dep.ml and click OK. So kind, again it's a deployment and let me remove that kind, and then yeah, deployment is absolutely fine. Then metadata name immediately have to change. This time I'm gonna give redis -f and spec. So literally it's better to copy this, it would be much easier. Redis l dep. Okay, let's edit here only, it would be much easier. Okay, f, then labels will keep it same, follower, backend and spec, but the replica I want two. The replica set object I want two. So that's what I said, two. And selector match labels, app redis, and a remaining template, follower, backend, all fine. Now let's directly come to the spec, the container section. So in container section, the name I'm going to give as a follower. The container name is follower, and then image name I'll get it from somewhere else, not this one. I will use a different name who acts as a follower to that. Okay, so what I'll say is gcr and then IO. It's a Google container registry. From there I'm going to get that. So Google underscore samples and GB redis redis, and this is the name follower and version 2 tag. Okay, so let me cross check it. gcr.io Google samples GB redis follower tag 2, all fine. So resources will keep it same, requests everything fine. Port, container port is 6379. So this is what 6379. This is what it has to target. So let me copy everything and create vim. It's redis f and it's dep.aml and paste it everything. WQ save and quit, and it's time to apply the redis deployment definition file using apply the redis deployment using the following redis fdep.fml aml file. So kubectl apply option F, and it is redis f dep.aml. So let me execute that. Yes, you could see that deployment.apps, the redis f also been created. Now let's look into the deployments. Clear the screen, and what I'm going to say, kubectl get deploy. Yep, yeah, so you see that, redis f and 2 by 2, basically it's gonna bring two ports. That's the reason it's saying 2, and up to date are 2 and available are 2, and that just 23 seconds ago. So what I'm gonna do is I'm gonna fetch all, because this deployment is going to bring one replica set object and two ports objects and one deployment. So that's why I'm gonna say kubectl get all, and you see, yes, here is that. You got that pod redis L, this is old one, 14 minutes, and pod redis F2, two pods has been created, because that's what the replicas number we have mentioned, and the pods has been created, the pod object has been created. Then you see this is redis f deployment object has been created, and here you see replica set 222, all 222 has been also created just 59 seconds ago. So all done, all set. So let me mark this. So second step, follower step is also done. Then it's time to go for the fourth step. What's that? The fourth step is this is our front end. It's time to but before that we need to create the redis service, redis follower service. Let's do that. Let's quickly do that. So this is done. Now let me say redis follower service. So the guestbook application needs to communicate with the redis followers to read data. To make the redis follower to discoverable, you must set up another service. This time I'm gonna say redis f and svc.ml, and by and large I will use the same one. I'll copy paste this service redis l. Yeah, so with version service and then here I'll say redis f, and then labels are fine, selector are fine, target port, spec ports 6379 is fine, but one more thing we want to attach here is after the port, you remove the target port. After the ports, I'll attach selector. Okay, selector is already there. No? Yeah, okay, it's done, all done. There's nothing much to add. Ports is 637 and this is a backend one. So rest all fine. Let me copy this quickly. And here I'll say same vim redis f and this is svc.aml. Paste it. Save and quit. And run. And now it's time to create our redis follower service object. So kubectl, apply, option F, and file name redis follower and svc.aml, and here is the redis f is created. Okay, now let me check the services. kubectl get svc, and you should see redis f service as well as redis l service. Redis l service 9 minutes ago it was created. Redis f service just 13 seconds ago. So that's it. I think in this picture all set till now. So now let's move to the fourth step. So the next step is to set up and expose the guestbook front end. This is what front end pods with the front end containers. So now that you have the Redis storage of your guest book that's up and running, we have our guest book storage, Redis storage, these databases which are up and running. Now it's time to start the guest book web servers. These are the one guest book web servers, these three pods. Like the Redis followers, the front end is deployed using a Kubernetes deployment, because when you use a deployment, you can also bring up other objects like pod replica set. The guestbook app uses a PHP front end. It is configured to communicate with either the Redis follower or leader services, depending on whether the request is a read or a write. The front end exposes a JSON interface and serves a jQuery Ajax based UX user experience. Okay, let's create the guestbook front end deployment definition file. What I'm gonna say is front end dep, that's more than enough, .ml. So we will take the similar one. I think we'll copy from here only existing ones. Yeah, paste it, and now let's customize this to our front end. Let's begin. It's apps v1 deployment is absolutely fine. The name I'm gonna give is just front end. That's it. Front end. That's the name of our guestbook front end deployment. Then we have metadata, and after that labels are not required in this section, so let's leave it like this. I'm gonna remove. Let's move on to the spec directly. Spec, I want to have a 3. Yes or no? Let me check. Yeah, 3 pods. I want 3 pods. Yeah, so I'll change it to 3 pods. Then selectors. So here a name is front end. So match labels, I'll go with the guest book. Here the name is guest book inside the match labels. I'll say guest book. Then tire, it's front end. Then template, metadata, labels, I'll keep the same one. This is guest book, and this part is not required. I will remove that. Tire is front end, not back end. Yeah, and then we'll move to the specs. So inside the spec, so by the time it's not required this part, labels and metadata, this part is more than enough. Yeah, let me come to the containers section. In containers, the name I'm gonna give to this container is, this is PHP based and redis backend. So that's the reason PHP redis. And image, so GCR, I'll copy this directly from I think it's F. This is not F, this is F. And from here I'm gonna copy this image, so we will just modify it. Front end, yeah, paste it. gcr.io google samples gb, and google samples is fine. Then gb, here I'm gonna say front end. This is guestbook and front end version 5 tag. This is tag 5, and I want to attach some environment variables here. So env name is get hosts from, that's the environment variable, that's the key, environment variable key. And after that I'm gonna attach the value, that is value is dns. And remaining resources, request CPU memory, fine. Port container, this is 80, this is 80. That's it. So let's save this and control A plus and control C. So everything been copied. Then into the server, Kops server, then clear the screen, say vim, and name is front and dep.aml, and insert, paste the aml definition file script, then say wq, save and quit. Now run it. Let's create the front end deployment object. So kubectl option F, sorry, apply option F, and front end dot app, that's it. Deployment dot apps front end is created. Let me check the front end. Let's query the list of deployments that are available first. So kubectl get deployee, and here it is. Front end 3 by 3, because that's the replica set. We have mentioned 3 pods, up to date 3 available just 17 seconds ago. So what I'm gonna do here is I'm gonna try to fetch everything. kubectl get all, whether all objects has been created or not. As absolutely, you see that 3 pod objects, and this is our deployment object, and this is our replica set object. You see that these are 3, current 3, ready 3, and age 39 seconds just. So it's been created successfully. So now our all 3 objects, you can see that if you want to fetch only 3 objects specifically, only 3 pods, we can say 3 pods. Okay, and here is that our front end pods, 3 front end pods. I'll show you that. Total how many pods we have? You see that total 6 pods. I'll show the diagram here. 6 pods. We do not know exactly which pod in which instance, okay, in which working node. That we are not sure. But still we have 6 pods, 2 redis F and 1 redis L, and 3 front end pods. Okay, that's it. We'll mark this, write and create front end deployment. Then our next step is to create a front end service. Okay, front end service. Let's do that. Now it's time to create a front end service. The redis services you applied. The redis services you applied is only accessible within Kubernetes cluster because the default type of service is cluster type. A cluster IP type service provides a single IP address for the set of ports the service is pointing to. This IP address is accessible only within the cluster, within this cluster. But we want this to be exposed to the external outside network also. For that, what we need to do? If we want guests to be able to access your guest book, you must configure the front-end service to be externally visible so a client can request the service from outside the Kubernetes cluster. However, a Kubernetes user can use kubectl port forward to access the service even though it uses a cluster IP. Let's do that. So let's create our service. Front-end service dot front-end service. So the name I'm gonna give is front-end svc.ml. So what I'm gonna do is simply I will use the existing svc code. I'll just copy it and paste it in front-end svc.ml file. So let's begin. The name is kindly service metadata. Here I'll say front-end. Then labels should be changed. This is guestbook, and this is not required at all. This is front end and spec. So in spec, we'll keep the selector. We'll copy these two things exactly. So I don't need to type it again. So let me paste it here. Yeah, fine. So now port, I'm gonna go with 80. Yes, port is fine. Selector is fine. Okay, that's absolutely fine because we will save this and we will run it. See. So let me get into our instance. Here I'll create one more file, vim. This is front end svc.ml and insert mode, paste it, wq, save, clear the screen, and let's create the service. Let's create the front-end service. kubectl, apply, option F, and the name is front-end svc.ml, and your service front end has been created. Now let me see, kubectl get svc. Here it is, front end. But the problem here is this is a cluster IP because we have not mentioned any specific type here. We did not mention any specific type. If you don't mention any specific type, by default the service will be of cluster IP type. You see that, the cluster IP type. Now how can you access if it is a cluster IP type? The only option that you have is viewing the front-end service via kubectl port forward. So we have to run kubectl, then we have to say port forward, and then service name is front end, correct? And you could see that front end only. Front end, then how do you want to forward it? 8080 of the port. Let me cross check that whether it is 8080. Let me get into the front end. The deployment, yeah, it's 8E. So now we want 8080. This, what if you get a call to the 8080, it should be forwarded to port 80, and at port 80 you have a front end pod. Inside that front end pod you'll find a front end container. That's what the magic here. Okay, but yeah, let me execute it and see. Yes, the response is this forwarding from, this is a local host IP 8080 to this, and forwarding from this IP to 8080 this, and we can able to access it using local host IP. Okay, that's it. It's absolutely fine, no problem. But to view this, we can, if you from localhost we can view it, but this is not the production ready case, because using cluster IP you cannot do that. So that's why what I'm going to do is I'm going to do Control C. I'll come out of this, I'll clear the screen, and kubectl get svc. You see that? So now this is not production ready. In this way we can't do. So what is required? Here we require a load balancer type service. So if you deployed the front end svc.yaml definition file with type load balancer, we can find IP address and we can view our guest book through our browser, or we can give that IP address to anybody. Anybody can view our guest book application through their browsers, through internet. So for that, what I'm going to do is I will get into the svc file and I will attach a type, and type, that is what type it is. It is load balancer. That's it. You see that? It's done. Now I'll copy this. So now let me do ls. You see that these many files we have, total 6 files we have created, 6 definition files we have created so far, out of which I need to change this front end svc.yaml. So for that, what I'm gonna do is I'll say vim frontend svc.yaml, and I'll say percentage d. So all gone. Now in insert mode, and let me paste it. Okay, this is a wrong one, sorry. Yeah, again I'll say percentage d. Everything should be gone. Now let me copy this properly from here and I'll paste it there in spite of editing. Yeah, you see that? Now this time load balancer, rest all same, but the only thing we have attached is a load balancer. So now let's apply the front end service from this and we'll see. kubectl apply option F front end svc.yaml, and the existing service has been configured. That means it has done enough changes to the existing service, configured existing service. Now let's check what had happened to the existing service. So kubectl get svc, and here is that this time the service is of load balancer type. You see that? It's a load balancer type. But to access this load balancer and our front end application, we need to have this external IP. See, this is external port is mapping with the 30,064, which is the internal. So let me get into this diagram so that it will be clear. Still that it's done. Now we have created front end svc with load balancer. Yes, so far this is what we have done. So now Our load balancer is spinning. This is a AWS. Now this load balancer port is 80 is mapped with the front end of this front end pod 30,064. Okay. Now this is still pending. So what I'm going to do is I will get into our AWS Amazon Web Services and I will check the status of the load balancer, whether it's been created or not. So Amazon come. So this one, okay, let me close this. It's not required. Detail, close this. I am close this. No, cancel it. Okay, here I have. So let me click on load balancer here. Where is that? Load balancer network. Yeah, load balancing. So click on, open it on new tab. And here we should see, yes, that's it. You see that? Our load balancer just now, at this moment it's been created just now. You see that? And let's check the health condition of this load balancer. Let me click on this. Yeah, now we will enter into the load balancer. Let's check the health condition. So all fine, availability zones and status. This is very important. Health checkup. So 0 of 0 instances in service. So at this moment, no instance has been started. Let me look into the instances. So see, there are no instances, but you can see the availability zones. US West 2B, US West 2A. This is where our instances, our nodes, working nodes are present, and that's where our load balancer also being presented, being created. Now we should get two instances created. Let's wait for that. So it has done the health checkup, all fine. And listeners, so TCP load balancer port is 80, and at this port it is listening to instance port 30,064. Then here you can check the monitoring, and this is tags. You can see that complete information, the Kubernetes cluster, that is ours, kubewipro.imlac.com, and then Kubernetes service name, the service which is connected with this load balancer, that is front end. You see that front end, this is default is a namespace. Okay, namespace, and this is front end. Okay, if you want to see what is that, I'll show you that also. Okay, I'm gonna say kubectl get ns. You see that this is what the default namespace. You see, default namespace. Inside this default namespace, only all these services, pods, everything has been registered. So that's how it has shown. And this is wound. Okay, let's cross check this. Still, that's fine. So 80 is forwarding to 30,064, and this is our security group. These are some of the attributes about that load balancer, but I will refresh it and see what's the status. Yes, two instances in service. Fantastic. And here you see that instance ID. So two instances were properly connected in service. What are those instances? These are two instances are nothing but our working nodes. You see that name, at least you see the name. Okay, 2B, and you see US West 2A 2B, or if you have that tout for B85B D463, B85B D463. That's it. What a load balancer has done so far is it has established a connection with our working nodes. That's it. It has established a connection with our working node. Now both the working nodes are in service. Okay. Now let me show you that. So with this, our load balancer is successfully running. So now it's time to get the AWS Elastic Load Balancing endpoint. For that, let me get back. So I'm going to say kubectl get svc, but let me clear the screen before that. So kubectl get svc. And now you see front end, this is our load balancer, and external IP, we got it. With this external IP and with port 80, we should be able to access our application. So you can copy it either from here or you can copy it from other part. Okay, you can copy it from anywhere. That's all up to you. Where do you want to get it? So what I'm gonna do is I will fetch it from AWS only. So here you have two options. Either you come here and just copy the DNS name from here, or else simply get to the load balancer console, a dashboard, and here you should see the direct copy option. Copy it. And the port mapping is 80. So I'm gonna paste it here, and the port is 80, and say enter. Magic happened. Here is your app. Here is your app. You see that? This is our guest book. So who's the guest today? Today's guest is Daksha. So let me submit it. And it's been submitted. And one more. So clear? So that's how we access, we use a multi-container. You see that? This is our AWS endpoint. We have done it. Now let me mark everything. We have validated it. We have visited that app also. So now it's time to clean up. But before that, what I'm going to do is, as part of our like overall project, we just want to scale this web front end. So we have only 3 pods. I just want to scale the web front end. We can scale up or scale down as needed because our servers are defined as a service that uses a deployment controller. So we will run kubectl scale, then deployment front end, and deployment front end dep, and option replicas. Directly you can use a replicas option. Replicas equal to 5. Okay, front end dep is not there. That's fine. Let me check it. So kubectl get deploy. Yeah, it's front end. It's just front end. Sorry. That's my mistake. Yeah. Okay. Deployment.apps front end is scaled. So now let me fetch the pods. So kubectl get pod. You see that? Just 2 were existing 20 minutes, 3 were existing 20 minutes, 20 minutes, but 2 were added 13 seconds and 13 seconds. So that means to these 3 pods, 2 more pods were added into the working nodes, node 1 and node 2. Let me get back to this. So that's how you can easily scale up your pods without any difficulty. So that's the power of Kubernetes. I think as we work more, we will feel and we will experience the power, the ultimate power of Kubernetes or Kubernetes. So now we can also basically scale down. We can also scale down this by running kubectl scale, and again similar deployment, and it's front end, and this time again replicas. This time I'm gonna make it 2. Now you see that again the front end has been scaled. Let me say kubectl get pods gone, gone, gone. 22 minutes and 86 seconds. That's it. Remaining 3 were gone. So let me make it normal. I want to run it 3 pods, not 1. So I will make it back to the normal. And then now let's see. So this is how I want to run. That's it. So all 3 are up and running. So now it's time to clean up. So all done. It's time to clean up. Step 7 is clean up. So deleting the deployments and services also deletes running pods. That's it. If you delete a deployment, it will delete running pods and it will delete a replica set also. So let's use their names to delete the multiple resources with one command, or we can either use um, labels or names, but we will use this term a label. Okay, not names. kubectl delete deployment and option L, it's app. Option L says it's a label, and label we have gave is app equals to redis. Okay, deleted. All front end one are deleted, and now this time I'm gonna say kubectl delete service and same. So redis F and L, both the services has been deleted. Now kubectl delete deployment, but this is front end, so I'm gonna mention not label. I'll just delete as a normal one. Okay, deployment. Now yeah, deployment front end directly. Front end gone. Similarly, service front end. I think service also we gave the front end name. It's all fine. Delete service front end. That's it. So now let's cross check whether we have left anything. All should be deleted by now. If not, we have to delete that also. So that's the reason I would say now kubectl get all. Okay. Oh, service is still there. I think it will take few more seconds to get closed. Before that, I will cross check others. Kubectl get pods. I think it's gone. Get pod gone. Kubectl get svc. Other than default one, all gone. Kubectl deploy gone empty. Then kubectl all. Let's see all. That's it. Everything is gone other than the default ones, and then the job that I have created few days before. Rest all is gone, completely wiped off. It's clean. Hence, cleanup is also done. So we have successfully finished this application, but let me close this with this. Getting back to our website and let me refresh it. It should be gone. Yes, it's gone. That means absolutely successful. Let me meet you in another example. Now we are gonna look into fifth exercise, which is deploying WordPress and MySQL with persistent volumes. This is a stateful application. So here, whatever a blog that you write, whatever that you enter into our WordPress application, all will be saved safely in our working nodes, in our instances, and after that whenever we want we can get it. So that's what we want to go with, the persistent persistent volumes. So this tutorial shows how you this tutorial shows how to deploy a WordPress site and a MySQL database using Kops cluster and kubectl and your EC2 instance and Amazon Web Services. So I'm gonna write what all tools we are gonna use here. So this is WordPress, MySQL site. Okay, so now prerequisites and tools required. So we'll begin with a Kops or Kops instance or Kops machine and Amazon Web Services ELB, that's elastic load balancing services with services linked roles. This is common, but specifically I'm mentioning here. This is required for our previous exercise also. Then we need to install kubectl in our Kops machine, and finally one more thing to be looked into is Kubernetes cluster should be created. So we have created a Kubernetes cluster in our previous example. You go to that video and you watch that and you set up the cluster first and you come here so that we can continue with that. So a persistent volume is a piece of storage in the cluster that has been manually provisioned by an administrator or dynamically provisioned by Kubernetes using a storage class. And we have a persistent volume claim. We call it as a PVC. Is a request for storage by a user that can be fulfilled by a PV, a persistent volume. So persistent volumes and persistent volume claims are independent from a pod life cycles and preserve data through restarting, rescheduling, and even deleting the pods. Even after deleting the pods, it's going to sustain with all these calamities. I'm just calling calamities, that's okay. It's like even after restarting, even after rescheduling, even after deleting the pods, still your data will be safe and secure. So that's what a persistent volume and persistent volume claim is gonna do. Persistent volume will persist your data and persistent volume claim will make sure you have got your persistent volume data. So activities to be done or steps to be done. So I am attaching that steps. Step 1, let's create persistent volume claims and persistent volumes, but before that we will attach this is as a step 2, and first we have to create a customization file attaching a secret generator. So step 1 is to create a customization file, k customization file with k. Okay. Then step 3, okay, sorry, in step 1 itself, in customization file we have to attach a secret generator, then mysql resource configs, then wordpress resource configs. That's what we are going to attach in this. And once it is done, we will move to the step 3. Here we will apply the customization directory, and final step, sorry, fourth step, accessing the WordPress site and creating a blog. Then step 5, cleaning up. Okay, these are the steps we are going to do it to successfully complete this exercise. Okay, so enough of speaking, it's time to create our file. So but before that, let me reiterate what the difference between a persistent volume claims and persistent volumes. So MySQL and WordPress each require a persistent volume to store data. Their persistent volume claims will be created at the deployment step. Okay, remember this. I am going to tell you now. So now what we are going to do exactly in this exercise, I just want to show you visually. Okay, so first one, this is our cluster. The cluster should be ready by now because you might have created this cluster in our previous exercise itself. So master node, working node, and another working node. Let me show this one more time so that it would be much clearer for you. See that 3 nodes, this is our cluster. This is a Kops machine is the one. Through Kops machine I am administrating this cluster, but Kops is not mainly part of cluster, our Kubernetes cluster. This is our Kubernetes cluster with 3 nodes. One is master node or control plane, and remaining 2 are worker nodes. Here is that. Okay, now what I'm gonna do is, first I'm gonna create a deployment. Okay, deployment of WordPress MySQL. Okay, this is WordPress MySQL deployment object. So when I create this, by default it will create a pod as well as it will create a secret file, because everything, all the objects, secret object and pod object and replica set object and volumes object, all I'm gonna attach with only one definition file. We call it as deployment definition file. When I execute the deployment definition file, all objects will be created. Okay, so that's WordPress MySQL, and once that is done, I'm gonna create the service. That is WordPress MySQL service. Then after that, at the same time, the volumes will also be created. Okay, this is our volumes, persistent volume claim. Okay, this is for the WordPress MySQL. This is for the MySQL database. Okay, And similarly, we will create another deployment definition file, that is WordPress. And again, we will define secrets, we will define replica set object, we will define pod, we will define persistent volumes. All will be added, and then we will create this deployment. Then all the objects will be created. So again, then we will run the service for the WordPress, specifically WordPress. Once you run the WordPress service, obviously what happens, because we are running this service uh, basically of load balancer type service we are running. So when your load balancer of Amazon web services, that is EBS, elastic ELB, elastic load balancing, if that is spinning, that is running, that means you can able to access this from outside network through ELB endpoint. That's what we are gonna do here. So here, so MySQL and WordPress each require a persistent volume to store data. Okay, that's the main important aspect. So their persistent volume claims, you see that this is MySQL persistent volume claim. Their persistent volume claims will be created at the deployment step itself. Now, many cluster environments have a default storage class installed. So when a storage class is not specified in the persistent volume claim, if storage class, I'm going to show you that, if it is not specified in the persistent volume claim, the cluster's default storage class is used instead. So that's why we have to mention the storage class specifically. When a persistent volume claim is created, a persistent volume is dynamically provisioned based on the storage class configuration. So now it's time to put our discussion points into action. But before that, let me take the sticky note. Yeah, our first step is to create a customization file. Okay, let me get into my Kops machine, and I think, yeah, clear the screen. CD root def and ls, and cd it's Kops ls. So here I'm gonna create a directory saying mkdir, it is WordPress site, cd WordPress site, ls, nothing is there. So let's create our first file called customization.aml, KUSTOMIZAION.ml. Okay, before that, what I'm going to do is, in spite of that, we'll follow the same method, the status quo method. Let me get into the directory Kops. So here I'll create the folder saying WordPress MySQL blogger site, and inside that I'm going to open Visual Studio Code, and let me create a new file saying the file name is customization.aml. So here, what is a customization.ml? Here we have to add a secret generator. A secret is an object specifically. See, we have discussed a lot of objects in Kubernetes. A secret is an object. What does it do? It stores a piece of sensitive data like a password or a key, since okay, but recent one 1.14, the latest version, supports the management of Kubernetes objects using a customization file. You can create a secret by generators inside the customization file. So that's the reason where I'm using a customization.yaml. So let's add a secret generator in customization file. So let me say secret. Yeah, you see that? Secret generator. Click enter and then name, and name I'm gonna say MySQL. This is the MySQL password. So MySQL pass, and then literals value. So value I'm gonna attach as password. Yeah, password that's equal to uh, pass wd. That's fine for me. Pass wd. That's it. Okay. Secret generator, name, literals, and password. That's it. For now, let me save this. We will get back to this file again. So let me copy this first and get into our server and vim customization.yaml. I hope spelling is correct. KUSTOMIZ. Yeah, correct. So insert mode, paste it, W, okay, WQ, save and quit. Okay, so now we have attached our secret generator in our customization.yaml. So now we have to add a resource configs for MySQL and WordPress. So let me mark this first. So customization, it's done. Now it's secret. It's a MySQL resource configs. Let's look into that. Complete configuration. Now let's make a definition file which consists of all the information. Basically, the definition file that we are going to write describes a single instance of MySQL deployment. Only single part, basically a single part of MySQL deployment. If you want, we can attach a replica. That's not an issue. That we'll do it later. That scaling up and scaling down, we will do it later. So the MySQL container, and we are going to mount a persistent volume at where lib MySQL. This anyway we know. And the MySQL root password environment variable sets the database password from the secret. So these are all things we are going to do one by one. Okay. So let me get back to my VS Code and let me click on new file. So file name is MySQL, and what I'm going to say is dep. That's more than enough. Dep.yaml. So this is MySQL single pod deployment file. So as usual, we'll begin with service kind and service and metadata. Name I'm gonna say WordPress, WordPress, sorry, WordPress MySQL. Okay, and then labels, I'm gonna attach labels also. So below that name, labels, just one, it's app and it's WordPress, nothing much. So that when we want to delete using this, by mentioning app WordPress, all can be deleted with one click. So that's the reason. Now let's go to the spec. Inside the spec selector, so inside the selector app, this is what I want to select, this using label, this label. So I'm going to use that label. It's a WordPress. Okay, then in addition to that, I want to add one more label, that is tire, and it's MySQL database. So MySQL. and ports, yeah, ports, it's a port 3306. Target port is not required for now, so let me say 3306. That's it. So now target port we will remove, and inside the spec at the selector indentation we are going to add one more, that is cluster IP. You see that you got the cluster IP. Let me click on, and none. So that means by default it's not a cluster IP, so it could be some other one. It's not cluster IP, so we are saying cluster, it's not a cluster IP service. That's fine. So that's it. The service for MySQL has been added. Now what will we do is we will add few more. So with till this you give this three hyphens. That means the service object definition file has been closed. Now we will enter into the next. We will write a persistent volume claim definition file in the same file. Okay, for that I'll say kind and persistent. You have see persistent volume and persistent volume claim. So I'm gonna click on persistent volume claim. We got it? Yeah. So persistent volume claim, metadata, I'll go with MySQL PV claim. That would be better. MySQL PV and its claim. Okay. Then labels, I'm going to attach labels and app, and this is WordPress. Okay, same label and spec. After that, inside the spec, let's get into the access modes directly. So access modes is a read write once. That's it, nothing much, because this is the persistent volume claim. What we are asking is we are asking the persistent volume to read and write once from our side. Okay, we will do that. We should have that access to read it and write it once. Okay, so in addition to that, resources, inside the resources, request storage size, I am going to put 20 gi, 20 capital G and small I. And volume mode, it's a file system. That's okay, it's not required for now. Let me remove that. Okay, rest all fine. Let me move forward. That's it. So our persistent volume claim also has been written. Let me write. So what all we are attaching to that file. Okay, where is that? Here. Yeah. Inside customization is done. Now we are writing MySQL resource config, or in other way we can say that MySQL dep MySQL deployment definition file. It consists of all. So let me, inspired of this, I'll say 1 dot 2 dot, yeah, 3 dot. Now let me give hyphen. Yeah. So first we have attached inside this service object def file. Service object definition we have attached. Then we have attached the persistent volume claim, persistent volume claim object definition we have attached. Now let's see. Then after that we will add a deployment inside this file. Okay, let me say kind and its deployment. Yeah, that's fine. So deployment app metadata name, I would say WordPress MySQL. That's done. Selector directly will, okay, labels we will add. So label, because we have to use it later. So app and it's WordPress. So selector match labels. Inside the match label, we'll use the same label WordPress. Then only it could be matched. Then I will attach one more. That's a tire. That's what we have mentioned on top. Okay. This is MySQL. Tire is MySQL. So then we will go for template. Okay. Template. Yeah, it's fine. No. Yeah. Template and metadata. Template should be with the strat. Okay. Match labels tier 1, and below that I will attach strategy. I will attach strategy to the selector well. Okay, there is one more thing gone out of that. Let me cross check. Metadata, then spec. Okay, the spec and selector gone merged. Spec, selector, and yeah, selector match labels, and it's a app. Correct. Yeah, now it's fine. Now let me put a strategy here. Yeah, came strategy type. I'm going with type recreate. Okay, then let me go for the template. Let me make it. Let me take it up. Yeah, template. Then metadata. Then labels. Inside the labels, I will attach app. So let me, yeah, app. Again, it's a WordPress, and tire, a tire, and it's a MySQL. Sorry. Yeah. Then now it's time for attaching the containers. So spec containers, and name of the container I'm gonna say is MySQL, and image I will bring it from, so my Docker, that's a MySQL 5.6, that's the version I'm using. Then I have to attach the environment variable. This is very, very important because I have to define the MySQL root password. So env the name, first name, so I'd say MySQL, it's a root password, MySQL root password. So the value I'm gonna add, so directly I won't add, I will add value from, and value from where, secret key ref, that's where I want. And okay, not key directly, I will attach the name first from the secret key ref. Okay, name, yes, name, and it's MySQL pass, you see that, MySQL pass, and and password I will attach here directly. I'll say pass. Okay, just a minute. MySQL pass, and it's pass WD. Okay, you see that it's a MySQL pass. I have used, instead of using secret object, I have used a secret generator using customization file, because this is the latest advanced one. So pass WD is my password. So pass WD, and MySQL pass is the ref, the name of that key ref. Okay, so then coming to the resources, so environment, coming to the resources and close to that ports, let me change the ports first. Then I'll get back to that port. Container port, it's a 3306. And then resources, I don't think it's required. Let me remove that. Yeah, I'll remove these resources. That's fine. Then after that ports, I will name, I'm going to provide name of that. Name, it's MySQL. So that's what MySQL pod, a container, MySQL container port is that. Then I will attach volume mounts, not devices, volume mounts. And then mount path, I'm gonna say var /var lib. That's what the standard place where we'll have a MySQL databases and logs and everything. So that's what I'm giving. So var lib MySQL, and the name of this, what I'm going to say is MySQL persistent storage. Okay, done. So let me attach these volumes to our. Okay, let me attach these volumes and the containers. Okay, just let me cross check. So volume mounts, ports and volume mounts are at the same indentation level. Container port name and then volume mounts. Okay, volume mounts, this should be at this indentation level. Okay, no, that's the name. Yeah, correct. Mount path and name. Mount path should be this indentation level and name should be this indentation level. Yeah. Now let me attach here. I think there is not equivalent, just volume is on containers level. Yeah, let me say volumes here. Volumes, yeah, we got it. And name, volumes name, yeah, let me bring it here. Similar stage, that's fine. Name MySQL persistent storage. So that's what I'm gonna give. And claim. So claim name. So that's what I'm gonna say. Persistent volume claim. And what is that persistent volume claim name? Let us scroll up, and because we have attached that persistent volume claim, see, this is what, and this is the name. Okay, just let me copy this from here. Copy and paste it here. Yes, it's done. Now that's it. That's all. So we have attached. Anyway, secret was attached in customization.yaml about the MySQL password, root password. Then we have attached the persistent volume claim, and then deployment. Inside the deployment, we have attached the persistent volume also. So let me write down here. So this one is done. Secrets using secret generator. Then claim pod and PV persistent volume is also given, and replica is not specifically mentioned. Anyway, one pod, so pod object. That's it. These are all objects that are going to be created from this. Okay, that's fine. So now let me copy this. So vim. So what I'm gonna say, the file name is mysql dep.ml. So vim mysql deploy dep.ml, insert mode, and paste it here and click escape, shift plus colon and wq, save and quit. So that's it. So now we have to create one more manifest. You see that one more, let me get here. Yeah, so this is done. The first definition file with all objects. So now we have to create a WordPress resource config, WordPress resource definition files. In this definition file we are defining all the resources, so we are going to do that same. So here in WordPress resource config file or resource definition file, again a single instance WordPress deployment. Okay, a single pod, a single instance WordPress deployment. The WordPress container mounts the persistent volume at var www.html for website data files, and the WordPress DB host environment variables sets the name of the MySQL service defined above, that we have defined in our previous. So in WordPress DB host, the environment variable should take the MySQL service name, so that this data will be stored there, and WordPress will access the database by service. Again, I'll show that. So what I'm talking about here is, see, this is what our MySQL, WordPress MySQL, and then, okay, so far what we have done is, this is what we haven't done, but we have created a file so far. And after that, after creating the WordPress pod and after creating a WordPress service, this WordPress, we will give one environment variable, that is WordPress DB host, database host. So where is that database? We have to give the service name to this as a database environment, database host. Then automatically WordPress uses that MySQL pod as MySQL container as the database. I hope you got it clear. Then similarly, we have to set the WordPress DB password environment variable, the database password from the secret customized generated. Okay, from that secret generator, we have to set that also. Okay, same password. We'll take the same password. It's not to worry. Okay, let's get into the action. We will write our file first. So points to be remembered here. So in addition to this, these parts will be remembered. Like these parts will be uh, redoing the same thing, PV claim, all those things. But two important points to be noted down here is, one is persistent volume. PV will be at /var www and HTML. And second point is we have to set up the WordPress DB database host, and this should be given the MySQL service name. And next thing is the final environment variable that we have to set is WordPress database password. So here we are going to attach the password. Basically, we don't attach the password directly. We will refer this password to the customization.yaml file. Okay, this is a refer the password. Refer MySQL password. Okay, these are all important aspects that we want to do. So now let's get into action. We'll create a file. So file name, WordPress dep. That's it. Yeah, let's begin. Let's begin with service as usual. We'll begin with service. So kind, no, or else I'll copy that. That would be better. I'll copy it and oh, okay. If copy and that's not a good idea. So kind is service, and I clicked it, and I'll remove this one, and name of this service is different. I'm gonna say WordPress. The service name is WordPress, and labels I'm gonna attach same labels. Let me copy this mysql and Kops directly. Come here. Yeah, label this labels. I just want to copy because all can be deleted at one go, and paste it. Yeah, label proper indentation, no problem. Yeah, then app WordPress label spec, and inside the spec let me go to the selector will have one is app and another one tire. That's this is same front end, but this time is front end. There it was database. You see that it's a mysql, and here it's a front end label. Tire is it's a front end label. Okay. Then before I'll set up that what type of thing I'm gonna use this service, whereas this service it's a cluster IP, even that's also none. So but this I'm gonna go with we'll see. So this is done, selector is done. So selecting this from this app label, my app. Okay, sorry, I have to change this, not my app, it's a WordPress. Okay, then port let me give 80. Okay, this one I don't require because I'm gonna go with a different type of yeah, I'll go with type. It's load balancer. Yes, you see that load balancer. That's it. Our service file is ready. This is a load balancer type service, and let me go to that, and you should see the service name of this. This is WordPress MySQL. I'll copy this because we have to use this later to set up as environment variable of you see that. I'll paste it here. So now get back to that. So we will create now persistent volumes. So again, kind, this time it's persistent volume claim, and persistent volume claim as usual. It begins we will name it, this time it's WP PV claim. That was MySQL PV claim. This is WP PV WordPress PV claim. Okay, done. Then we will attach labels to this. Let me copy the labels directly from here. Yeah, yeah, and it's where is that? Yeah, metadata name. Let me paste it here. Correct. Labels app WordPress, absolutely fine. Now it's time to add spec. Inside the spec, let me directly go to the access modes. Read write once is absolutely fine, and then storage I will give 20 GI. Then file system is not required. I'll remove this. Yeah, that's it. Our persistent volume claim is ready with WPV claim. Okay. Now let me close this, and now it's time for deployment. It's time for deployment. Kind deployment, and let me attach the name first. Okay, something wrong. what I'll do is I will delete all this. Basically deployment by and large same, other than uh, environment variable. So I'll copy this exactly from here to here, and I'll change the names. Okay, yeah, here, correct. So now let me scroll up. Yeah, deployment name, it's WordPress, nothing much, just WordPress, not MySQL. So I'll make it WordPress, and labels remain same, app WordPress, and spec selector labels remain same. Tire will change to front end. Okay, yeah, you got it. Let me scroll up. Where is that? Yeah, here. Yes, correct, absolutely correct. Yeah, spec selector. This is deployment, correct. Yeah, then strategy we will keep it same. Recreate, match labels is done. Template, let's get into the template WordPress, and then tire, it will change, it's a front end. Done. Then let's get into the important one, the most important one. That's a container section, a specs container section. So the name I'm going to say of this container, it's WordPress, and then image. So I have to fetch the image. It's WordPress, and then with tag 4.8 Apache. Okay, 4.8 Apache. Then environment variable. The first environment variable for MySQL was MySQL root password, but here I'm going to attach WordPress DB host. This is pretty important. WordPress. Without that, we cannot establish a connection itself. DB host. Okay, WordPress DB host. And then what was that? We have written also here. WordPress DB host is the WordPress MySQL. That's what the name value. That's what the value is. I'll copy this. And where is that? Yeah, here. Value from. Oh, sorry. Okay. Ah, yeah, here is that value. So name, and then below that I have to attach a value. So value, and it's WordPress MySQL. Okay, then I don't require this. I will attach a one more uh, basically one more environment variable. Yeah, it's done. Name, then this time I would say WordPress DB password. WordPress DB and password. But let me confirm. WordPress DB host, WordPress DB password. Absolutely fine. So password as usual, we'll get it from value from secret key ref. That's MySQL, and the password that I have gave is passwd. So all done. Now it's time for the ports to be attached. So this is port container port. I'll go with 8080, and name I'm gonna say WordPress. Then volume mounts. So volume mounts, first I'll give the volume mount path as we have discussed, as we have noted down. It's var dub html. Yeah, var dub html. Let me paste it here. Yes, it's done. The name of the volume would be WordPress persistent storage. Okay, WordPress persistent. Yeah, that's it. The volume mount, we have given the volume mount path, and then the name of this volume mount is this. So now I have to add this volume mount to volumes. So let me change this, not this one. So I'll say WordPress, and you see that you got it because here we have attached, and automatically it will get auto populated. Then persistent volume claim, the name I'm gonna give is, of course we have given it already, so we will get it this. Just let's say WP. Yeah, you see that you got it. Yeah, all done. Let me save this and Control C and come to the server. Oh, before that, let me do this. Okay, these all steps are done. Clear? So now let's get into the Kops. So Vim. So this time what I'm going to say, WordPress dep.yaml, and let me say I and paste it. So everything has been pasted properly. Let me say WQ and close it and clear the screen and say ls, and you see at this moment you have three files, three YAML files, three definition files, three configuration files: customization.yaml, mysql dep.yaml, wordpress dep.yaml. Okay, so now, so what we have to do is we have to add a few more things to the customization file. What are those? We have to add these names, exactly these names, to the customization file, and we will execute all. We will create all the resources and all the objects directly from the customization file. That's what the plan is. So what I will do is I'll open that again. Vim ku. Yeah, we opened it. I'll make it insert mode. So now I will add them. No, or else what I'll do, I'll create that. I will add them here only. So then we won't face any indentation issue. Okay. So now I will come here. So I'd say resources. You see that auto populated. Let me click on this resources, and then let me give all. So one is MySQL. You can see the name of that file, definition file here, MySQL, and it is MySQL dep.yaml, correct? And another one is WordPress dep.yaml. I hope it's correct. Yeah. What MySQL dep WordPress dep.yaml. Correct. Yeah. Let me save this. Copy and say %d. Let me remove all those things, and now let me paste it. Okay, we got it completely, and it's MySQL dep and WordPress dep. I hope spelling is correct. And let me do WQ and do ls. You should see all the files. Yeah. Okay, MySQL dep and WordPress dep. Okay, correct. So now it's time. So let me show the diagram one more time. So this file has been created. This volume claim, persistent volume claims has been created for both, and both the services has been created. Now let's make it blank and let's run the let's apply all the things. So it's very simple. Now we are going to use customization technique. So that's the reason we can directly apply at a time. So kubectl and say apply, and option K, simple. K says we are using a customization.yaml file, customization configuration file. So that's why you have to put K, not F. Okay, K, and do it that customization file is in present working directory. That's what it says. Now let me execute. That's it. Okay, you see that secret service WordPress has been created, service WordPress MySQL has been created, persistent volume claim and persistent volume claim and deployment WordPress is created. Okay, total how many? Two. Okay, 7. So now let me first get the deployments. kubectl get deploy. Yeah, so not yet ready, so that's why we'll wait for some time. How many deployments we have created? 2 deployments. One is WordPress, other one is WordPress MySQL. I'll show you that. So this is WordPress and the name of this is, I'll show you. You see that the name of this deployment is WordPress deployment, and other one, the deployment name is WordPress MySQL. You see that WordPress MySQL. Okay, so 2 deployments got created. So let me, so it's still taking time. By the time, let me get into that. So now 2 deployments were created. That means our WordPress MySQL database pod has been created. The container is spinning, and similarly WordPress MySQL service is also started. I'll show you that. And then similarly WordPress pod is also spinning, pod is also running, and container is also spinning, and then persistent volume of that, and WordPress service has also been created. Okay, till now it happened. Let us cross check all those things. So let me check kubeset deploy. Okay, it's taking more time. WordPress, it's taking more time. And let me check at least services. Okay, first we'll check the kubectl get secrets. Okay, MySQL opaque. So as our customization.yaml file contains all the resources for deploying a WordPress site and a MySQL database, we can simply type kubectl and apply. Option K tells it uses a customization.yaml file, and that file is there in present working directory // and it's going to apply each and every, it's going to apply and it's going to create each and every object that we have defined there. That's it. You should see that secret MySQL pass secret has been created. That's a MySQL pass. Basically, the password is there inside that a secret object, and 2 service objects, and 2 persistent volume objects, and 2 deployment objects. Okay, let's get into it one by one. By the time our AWS load balancer will start, let me get into the load balancer and refresh it. Yeah, here it is. Just now it started 343, 343. You see that? Just now it started. By the time health checkups takes place and it gets up and it generates instances, you see at this moment nothing. By the time it happens, we will look into the each and every object that has been created so far inside our instance. Okay, so let me say kubectl. We will begin with the service only. Secret only, sorry, kubectl get secrets or secret, and you see that this is what our secret MySQL pass, this is what the name we have given. If you have a doubt, I'll show you that also. So here you have, see the name I have given is MySQL pass. If we can define the secret object using a secret file, that we have done in our course, but we can use a secret generator also. Okay, and that's created properly, that's done. Then we will look into the services. We have two services. First we'll see, okay, kubectl get svc. You see that this is the default one, and these two. WordPress just 115 seconds ago, and WordPress MySQL 115 seconds ago. Anyway, WordPress load balancer type, and WordPress MySQL cluster IP type. Let me show that also. WordPress, and let's directly go up. Service is second one, yeah. Little up below the secret, yeah. This is service, and you see that it's a load balancer type because this is WordPress. The name of that is WordPress, and type is load balancer. Similarly for MySQL, completely go up. It's WordPress MySQL name and it's cluster IP. And you see that names also matching WordPress MySQL and WordPress, and then cluster IP and load balancer. So once our load balancer is up, you would get the external IP to access that application that we are going to do and at this port. But for now, we will look into other objects that were created. The second one is persistent volume claim. So how can we see that? kubectl get pvc, and here you should see one is MySQL PV claim and other one is WordPress PV claim. Two objects has been created, and this is the volume name, PVC volume name, a volume tag, and capacity is 20 GB, capacity is 20 GB. So that storage in Kops, it's in Kops, okay? Storage in Kops. Okay, and what else is left? Deployments. Next one is deployment. That's WordPress and WordPress MySQL. So kubectl get deployments or deployee, and you see two WordPress and WordPress MySQL 0 by 1, 0 by 1 up to date. So they had to start completely. They will start in a minute. Then let me check. Obviously pod should start kubectl pod, and create container figurer. Okay, container figurer. Let me see. The problem is, oh, there is some issue with that. Let me check that. So kubectl describe and pod, copy this. I think problem in both WordPress MySQL as well as WordPress. So that means, so WordPress already present on machine. That's okay. So kubelet error could not find key passwd in secret default MySQL pass. Okay, in this it could not find passwd. Okay, what password I gave? So custom, okay, passwd, and come down, passwd, come down, passwd. Absolutely fine. What's the issue? Okay. So error could not successfully pulled image. That's not an issue. So kubelet and then WordPress 4.8 Apache already present on a machine, but that's not the issue, no? Including waiting. How about other one? So it could not find a secret in default. Okay, it could not find a passwd in secret. Okay, that's okay. Then other one, we'll look into the other one. kubectl describe get pod, and it's clearly error is the kubectl describe and pod. I'm gonna give wordpress mysql and let's see what's the issue here. Could not find key past wd in secret default key. Okay, I will do some changes to this password, and I have a container already present in on machine, a container image already present on machine. That's okay. So let me do the changes and we will execute again. So for now I'm going to delete all these things. So with one click, with one command, that is kubectl delete option k. So we have done some changes. Now let me reapply it and see. So all has been created unchanged. So created. Let me check kubectl deploy get deploy. Okay, it's getting up. It's one by one. It's up to date, and we are waiting for other one. So let me check kubectl get pod. Okay, both are up and running. It's brilliant. So now let me cross check the pod. Kubectl get pod, sorry, get deploy. Yes, both are ready, both are up to date. And meanwhile, let me get into our where is that? Yes, here. Yeah, this is our load balancer. I hope it's been just now created. Let me cross check it. The old one has been deleted. Yeah, see that? 358 just now. Okay, so let me get into the details of it and we will check the health check. So 0 of 0 instances in service, so nothing has been started as of now. Let's wait for some moment, and by the time we will explore this. So we'll look into one by one. kubectl get secret. Okay, mysql pass opaque secret. Then persistent volumes, kubectl get pvc, and in Kops storage is in Kops machine, and services will look, yeah, we'll look the services. kubectl get svc, and okay, still it is pending only. WordPress, this is that service, it's still pending. Let's wait for more moment, and it's a load balancer tab, you can see that clearly. We'll wait for some more time, and we will look into the pods. Okay, pods are up and running. So by the time, what I want to show is, I want to show this again. So our deployment files, so all the services has been running. So now at the end we have run the WordPress service, which is a application load balancer type, which we are using Amazon Web Services. Once this is up and running, so we can actually get the elastic load balancing endpoint. With that elastic load balancing endpoint, or with port, we should able to access the WordPress front end. Obviously, whatever we type, blocks that we store, all will be stored in the WordPress MySQL. And even if these existing pods will be changed and updated with the new pods, still all the blocks and all the data will be stored into MySQL PV claim. That's a MySQL persistent volumes, and after that, if you want to claim it and use it, connect it with the another pod, you can do it using MySQL PV claim. Okay, So let's get into that and we'll see what's the status of this kubectl SVC. Yes, you see that your external IP is there. Okay, now let me get into this and we'll see. Is there any change? Any instance is up? Is any instance the connection has two of two instances in service? Fantastic. So two of two instances in service. That means we can access our application. Let me get into that. So copy this DNS name and look here. A description and port mapping is 80. So no issue. So let me copy this here. And anyway, it's a port 80 default port. I don't require. Let me execute it. And waiting. And here is that. Let me say English or Karnataka, Kannada, Hindi, whatever you want, you do it. But I'm gonna go with English. Yeah, this is Telugu. This is Tamil. Tamil. Okay. Then I'm just finding that English. Okay. Yeah. I'll go with the UK one. That's fine. Okay. I have to provide some information. That site title. This is imlike blog. Username admin. Password. It's fine for me. I'll copy this exactly and put it in my we have done till here custom directory and accessing this. Okay, we are doing this also, so I'll paste this. Fine. So then email randomly I'll give and discourage search engines from indexing the site because after few seconds I'm gonna close this one. So install WordPress. So don't want to save it. So now it's asking WordPress has been installed. Thank you and enjoy. Login. Yes. So admin and password. I'm gonna get it from here and copy it. Admin. Paste it. Yeah, correct. Login. Yes, that's it. A WordPress blog website. This is yours from now onwards. Imlac blog, and let me customize my site immediately. Okay, it's fine. Let me save and publish. Let me hide this. Yes, this is a blog. Imlac blog. How is that? Let me scroll down. I hope you will like it. How is that? Brilliant? Fantastic? Do you like it? Or do you love it? How's that? Answer me. Answer me, yeah? Okay. So now let's write a blog. So about this site, and so let's get back to the society identity. You can edit whatever you want, and let me close this. Yeah, we are on to the main page. From here we can write our blogs. So click on pages media, yeah, post here, all new post, existing post is hello world. So I'm gonna attach one more post. Add a new post. Yeah, this is welcome to the Kubernetes. So invention of K8s is life changing. So things are pretty simple and efficient and effective with K8 Kubernetes, and even complex and huge, heavy applications can also be deployed and handled gracefully using K8s. That's it. It's more than enough. Let me make it and publish it. Let me add a quote and publish it. It's publishing, and you can see that, yes, that's the post. It's been published. So nothing to update. So that's my post, and let me get you could see all posts now. Let me click on view. Yeah, this is how it looks. Welcome to the K8s. Invention of K8s is life-changing. Things are pretty simple and efficient and effective with K8. Even complex and heavy applications can be stored. If you want to edit, you can edit it. But that's how this application works. From here itself, and this is the front end. This is how it looks to the external people. From here, basically, you can edit the post. You can add new post. You can comment it, you can plug in updates and team updates, and this is the dashboard. You can get back to the like blog dashboard, and if you want to attach the menus, you can attach. Okay, so that's how it works, and this whole data can be stored forever. So now let's get back to that instance, and sudo option I clear the screen. So now let us kubectl get all, and these are the services, these are the pods which are running now, and these are the services which are running now, and these are the deployment objects which are running now, and these are the replica set. Okay, replica set all are one each other. If you want to, you can increase the replica set in both the files, and you can basically use that object also. So we will do kubectl describe pod, and name of the pod is this. Yeah, okay. So created container, a started container. So successfully pulled image WordPress. So that's not an issue. Then pulling image WordPress. So all fine. Let me scroll up. You see that VP WordPress PV claim. And here you should see WordPress container ID information, WordPress image, Docker image ID, a replica set, and app. Yeah. Now let's look into the other one. So kubectl, describe, this time MySQL. Yeah, here container has been started, successfully pulled, and okay, a replica set MySQL. So all fine. WordPress. Okay. So now let's kubectl get svc, kubectl describe svc and WordPress. Yeah. Okay. You see that initially access denied and it took some time, and ensure the load balancer has been started. So now let's do for the MySQL, WordPress MySQL, and you see that namespace default app tire, and here endpoint is this is where it gets connected. kubectl deployment. Let's do that. kubectl describe deployment and WordPress, and 16-minute scaled up through here is that WordPress DB host is WordPress MySQL, and WordPress DB password is set to key password. Okay, this is what basically MySQL pass. And okay, var www html rest all it's fine. WordPress persistent yeah, persistent volume claim is uh this is mounts var www html, and it's connected with, okay, let me scroll down. Yep, that's it. So let's cross check our, so it's still up and running, we did not stop it. If you want to write, you can write a new post, a new media, a new page, whatever you want, you can do it, because this is your application now. You have hosted your application now. You can have your own WordPress website also with this. You just need to customize this, that's it. This is how a big complex application can be hosted. So let's get back to this, and you see that our application with the WordPress MySQL pod and WordPress pod with application load balancer, that's elastic load balancing AWS service is up and running in Kubernetes cluster, which is created by the Kops. So with this, we have completed all the activities that we have mentioned in this, other than cleaning up. So let me mark that. So cleaning up, I'll leave it, rest all are done. So let's get back to this. And now it's time to kubectl get all, and it's time to clean up. It's time to completely clean up. To do that, what I'm gonna do, it's one command, it's kubectl and apply delete option k and dot. Okay, we are in a wrong directory. Let me get into our directory first. Cd root def cop word, and let me give the same. That's it. It's gone. Now let me check it. Refresh it. Yes, it's gone. Let me cross check the pod. Pod is more than enough. Forget about the service. Get pod. Yes, no resources found in default namespace. Now let's see here. It's taking a lot of time, but it's gone. It will be gone. But we have to. Yeah, it's still getting refreshed. So now, yeah, it's gone. You see that? Now let me check the load balancer also. Let me refresh this. And by the time, yes, load balancer also gone. Now there are no load balancers at all. So now let me mark this up. So this also has been successfully completed. So with this, we have finished this exercise, a stateful application deployment also. So now we have to slowly increase our complexity, our application's complexity. So now we are going to look into more complex application, a multi-tier application which consists of lot of services, that is a vprofile application. So this consists of memcached, mysql, and databases, Apache Tomcat, and Elasticsearch. A lot of services it consists of, and that we are gonna do. So first we'll see the architecture of that application before we working on that. So it consists of following services: AWS ALB, so that will be attached when we create the services in Kubernetes. So take out that. Other than that, Tomcat is our application server that is going to have that's going to host our serve our application. Then RabbitMQ, it's a broker or querying agent. Then we have memcached or DB caching, Elasticsearch for indexing or search service. Then MySQL, it's a SQL database. So let's the setup should be in this order: MySQL database, memcache, RabbitMQ, Tomcat. That's application service, and we will see the vprofile web architecture here. So this is public network on left side, and then from the public network, so we'll use a load balancer specifically in the public network, or else we can this load balancer can be created through the this load balancer can be created internally inside our AWS CLB Elastic Load Balancing that we are going to use, and this is what. So this will be connected with a app tier tomcat, the front end page that we are going to see. So that's the front end page, tomcat. And once that is done, we are able to access. Then remaining all are internally connected. So the backend services such as queuing will be with the RabbitMQ, Elasticsearch, that's indexing with Elasticsearch, and we have databases MySQL and MongoDB, and we have caching, database caching, memcache D. This is our architecture. So now let's get into the action. So let's write down the steps that we are going to follow. So in our sticky note, so it's a vprofile, multi-tier vprofile project, and steps. Step 1, we have to spin a cluster. So basically we have to set up a Kops Kubernetes cluster, or set up a Kubernetes cluster using Kops. That's the first step. And step 2, we need a volumes. So create volumes and attach them in definition file for DB. Basically for database we require more volumes, so that's the reason we are going to go with that. Then once that is done, so we will start writing all the definition files, such as secret file first, which consists of passwords and usernames of all the databases, memcache, MySQL, MongoDB, and MariaDB, whatever it may be, all. Okay. Then after that we will write DB deployment definition, database deployment definition. Then after that we will write database service definition. Then after that we will write memcache deployment and service definition both. So memcache D deployment and service definition files. Then after that RabbitMQ deployment and service definition file. Then Tomcat, our hero, Tomcat deployment and service, again all service, so that they can internally connect it. Basically it's very it's a complicated to show in figure also. That's the reason I'm not showing on the figure, but you should be able to get it. And once it is done, we will create objects, all the objects using respective definition files. And then we will access our app and validate it. Then final step, cleaning. So that's what we are gonna do. So here we will write our files, we will write all the definition files in local machine, and we will push them into the GitHub repo. Okay, that's what we're gonna do. So let's begin our steps one by one. Step one is to set up a Kubernetes cluster using Kops. I have already set up this one in our previous exercise. If you haven't set up this, kindly watch that video and come back here with the Kubernetes cluster setup. I'll show you that. So this is my I'll get back to that EC2 dashboard and instance is running. These three are my Kubernetes cluster. This is master, this is node, and this is node. These two are working nodes and one is master node. So our cluster setup is done. So now the second step is to create a volume. So and attach them for a definition file in GB. So I will get back to our EC2 instance and not here. Yeah, here. So scroll down a bit and elastic block storage, you can see that. I'll click on this, open link on new tab, and let me close this. Yeah, you could see that I have created one block storage. That's this. It's a recent one. GP2 type 3 GB and IOPS. So if you want to create new one, you can create it from manually from here, saying how much size you want, and GP2 general purpose SSD and IOPS availability zone US West 2A 2B 2C 2D, whichever you want, and don't create a volume from a snapshot, and you can create it anyway. I have created it already, so I'll get back to my volumes, and this is the one. I'll select it and I'll scroll down a bit. I'll copy the volume ID. Yeah, here is that my volume ID. So, and it's in US West 2A. So I'll put it here because I'm gonna use this later. So it's a volume ID. I'll paste it, and zone is US West 2A. Okay, fine. So that's, we have created our volume, and zone is also we have taken the zone. So if you specifically want to label, you can also do that. Okay, let's create our own labels at the same time. So let me clear the screen. So let me say kubectl get nodes and show labels. You see that? You can find out the labels here. It's zone US West 2A. So total we have three nodes. One is t3.small and t3.small. These two belongs, these are two working nodes. These are US West 2A and US West 2B, and other one is US West 2A. So one is in US West 2A, other one is US West 2B. So we can use this labels as a zone, but still if you want to attach the uh, specifically zones, you can do that. But for that, what I can do is kubectl get node get nodes. So these are our nodes. Now we're gonna describe this to get the complete details about the node. Okay, so let me say kubectl describe node, and I'll copy that. The first one, it's a working node. I'll copy this one and I'll paste it here, and I'll set up a pipe, and I'll grep US East, sorry, US West 2. Okay, that's my mistake. US West 2, and you see that we got that it's US West, it's 2B. Okay, this machine belongs to US West 2B. So now let's label it. Say kubectl label nodes and let me select any one. So I will take this is the first one only I'm going to take, and I'll put it here, and I will label it as dot US West, and it's 2. I'll label it as US West, it's zone equals to US West 2A. No, this is 2B, US West 2B. So I don't want this. I want the one where we have created a volume so that I can attach that. So I'll take the third one, I think. So third one is in US West 2A. I think you see that, the third one. Let me cross check that also. I'll US West, I'll remove this from here, node, and I'll copy this third node, a second working node. I'll paste it here. Yes, this is in US West 2A. So now I will label it. So kubectl label and node, I'll paste that, and then zone. So that's how I want to label it, zone US West 2A. So this I want to attach. So it's been labeled. You can see that kubectl get nodes. So this has been properly labeled. The third one, B7. Okay, let me write that also. It's node B7 is in US West 2A. That also I'm going to attach here. Okay. Zone US West 2A. Okay. So step 2 is done. Now step 3 is to create definition files in local machine, and we have to push it into the GitHub. For that, what I'm going to do is first I'll create a GitHub account, GitHub repository, and then I'll start writing the files in local machine. So let's get into that. So where is my GitHub? Let me open it here. GitHub login, sorry. Okay, so let me go to my repository, your repositories. Inside your repositories, I'll click new, and I will say wipro-kube, and Wipro application multi-tier app, deployment using Kubernetes. So production ready cluster using Kubernetes production ready cluster. Production level cluster. Okay, so let me make it a public repo so you people can also access this. So I'll create a repository. Then let me get back to the directories. So here I'll first at this place I'll open VS Code, clone a Git repository, search, and it's vpro get kube, vpro kube, and I have to select the destination. Okay, that would be longer. So I'm going to select in like projects. It's where is it? K8. Inside that K8, yeah, here. So let me select this as a repository destination. So open in the same window. So now let me get back to that repository destination. I think it's here. K8 and vprofile and vprocube. Here you should see vprocube. So let's get into our VS Code now. So this is vprofile project. This is our source code. And let me get into the VS Code, and our source code is absolutely ready. So now we will start writing our definition files one by one. Writing our definition files, we will begin with the secret app secret.aml. So the folder, let me create a folder for that. Kubernetes or Kubernetes. Okay, you got that cube, and then I'll enter inside that, and here I'm gonna create my first file. You see that it's nested inside that, so it's inside that file. Okay, inside that folder. So the name I'm gonna give is app secret.aml. So kind is going to be secret only. Yeah, that's it. Now let me add data one by one. So kind secret metadata, name of this secret file, name of this secret object, I'm gonna give as app secret. These are the secrets of our app, so that's the reason I gave it as app secret. Then opaque, type is opaque. Now let's give a password information. Okay, so data. So we have two types, one is for the DB pass mysql, and so let me get that in an encrypted one. So for that I have to get into my EC2 instance, that Kops. So here, so one password I'll say wiprodb. Let me see, two passwords I have decided. Wiprodb, the initial one is, yeah, let me copy this wiprodb and say echo and paste it here as a string, and pipeline it to pipe it with base 64. We have discussed about this in our previous videos in detail, how to encode, how to decode and everything, so you can go through that. So let me copy this and paste it here. Okay, so then we have one more, the second one. This time it's RMQ, RabbitMQ pass, that's the name. And for that, what I've decided, I have decided to go with guest. So let me copy this and get into it, and let me Yeah, paste it here. So encrypting it, and okay, that's the wrong one. I want to go with the guest. I think it's password guest. Okay, now let me copy this jet3v1c. Yeah, and paste it here, and save this file. Our secret app secret.yaml file is ready, and in our videos we also have discussed how to create secret object. Okay, now what will we do is we will save this and get to this, and let's add this change to the staging area, and once the changes has been added, then we will commit. Okay, so changes has been added, so let me committing the secret definition file. Let me commit this. Okay, sync changes. Let me get into my GitHub, refresh it, and you should see kube. So inside you should see app.secretml. So let me get back and copy this. So I'll get into my EC2 instance and clear the screen. And here I will install git, and I'll clone that. So apt update apt install git option y. So install, so git clone and http URL. So not here, I will clone it into somewhere else. So let me enter into cd root defs cop and ls. So here I am going to create one more directory. This is vim viprocube. Vipro is fine. Vim vipro. Oh, sorry, that's not. ls cd rm rf vipro, and clear the screen, mkdir vipro. Now let me enter into vipro ls. Now let me do the git clone and paste it here. Enter. So it's been cloned. Let me check ls cd viprocube ls, and you see that we got that pom.xml, and we got the kube directory. So let me enter into the kube directory and do ls. We have that app.secretml. So let me apply this kubectl, apply option F and app.secretml. So our app secret has been created. So let me call that kubectl get and secrets, and here is that. App secret, it consists of data to 10 seconds ago and its type is opaque. Let me describe this so that we can see that kubectl get secret and then it's app secret. Yeah, sorry, I need to say describe. I want to describe it now, not getting it. I want to describe it. You see that? Now you got it. So it consists of two data points. One is db pass, it can and 11 bytes. Another one is rmq pass. It's a 6 bytes. Okay. So that's how we have created our app secret object from the app secret.aml definition file. So let's write remaining files also. So let me get to the explorer. So now I'm gonna write a second file. This time this is a database deployment file. Okay, so database deployment file. The name I'm gonna say is vipro db dep.ml. So this is a deployment file vipro db. So I'll say kind and dep. It's ready. Template is ready. Let me go up. Yeah. So rest all. Okay. Yep. So metadata. Okay. So metadata. So name. I'm gonna say Wipro DB. That's the name. Wipro DB. And labels. I'm gonna attach the labels to it. So labels app again Wipro DB. Then we have spec selector match labels. I'll change it to Wipro DB. Then template replicas I'm going to attach about the template. I can temp replicas. It's one. Then template metadata labels. Here I'm going to attach Wipro DB, and spec containers. So here I will write. I'll give this name Wipro DB and image. I will bring the image. Just a minute. We'll get into my Docker Hub. So Docker repository, you could see that kubechern, WiproDB, and version 2 see all, and copy this and paste it here and remove this one. Initial two commands, Docker commands. Yes, our image is also ready. So two more things we're gonna add. That's below the image. Args, that's arguments. We'll say ignore db dir equal to lost plus found. Clear? So then we will go for the volume mounts, directly volume mounts. Volume mounts, yes, we got it. And mount path is /var and lib mysql. That's what the mount path of uh, MySQL, and the name I'm gonna give is vprodb data. Vprodb data. Then we have port. After that, we'll attach our ports. So ports. Okay. Anyway, we have that. We will have the template at the bottom. That section port section. In ports, I'm gonna give the container port as 3306, and I'll attach a name to that. So container port, name vprodb port. Yeah, that's vprodb data. This is vprodb vprodb port. Yeah, and let me remove this one. It's not a list now anymore. So yeah, that's it. Ports is done. Now let me attach environment variable. Env name is very important. This MySQL, or else you cannot run database itself. MySQL root password, and we will get it from, so value from secret key ref, and name is app secret. Oh, that's what we have created now. And db pass, two things. Okay, then we'll go for the node selector. So if you remember, node selector at level of container. Let me go up, scroll up. Let me find out the level. Yeah. Okay. I think this is what the level of container. Yeah. So node selector, I'm gonna give node selector and zone. Okay, let me look into our this one. And what's the zone? Zone is US West 2A. US West 2A. Then volumes. We have to attach the volumes section. So name of that is vprodb data. It's there on top itself. Vprodb. Yeah. And so from where we want to attach that AWS block store. So AWS Elastic Block Store, correct? So now we need to give that volume. So again, this is, we have saved that ID. Yeah, this is, here is that volume ID. Volume ID. Let me paste it here. Then file system type, FS type. It's ext4. So fine, everything is okay. So now let me remove that resources which are not required. That's here. Yeah, so absolutely fine. Rest all. So let me save this. Then so next file is db service. Because our deployment is ready, next we are going to create DB service. So DB, and I'll say CIP.yaml. So this is a kind service, and yeah, so API kind service name I'll give wiprodb. So name I'll give it wiprodb, and selector. So before that, let me add inside the spec, I'm gonna add more data. That's a ports. The first one is ports. Ports, port, so 3306. Then let me add a target port. Yep, it's vpro db port. That's what we have mentioned in that vpro db port. Yes, this is correct, vpro db port. Then protocol, let's add protocol TCP. Yeah, done. Then followed by selector. Selector, I have to give the wipro db. Yeah, then okay, I missed this. Then after that, let me attach the type of service. That's a cluster IP. So that's it, absolutely fine. Let me save this also. So our app secret.yaml wipro db deployment and wipro db service is done. So now memcache. Next one is memcache. So memcache mc and cip dot yaml. Sorry, yaml. So memcache. This is again memcache service. I'll say kind. No, I'll just copy this from GB, so it will be much easier to handle. And memcache, paste it here. So the name will change, just Wipro Cache 01. Cache 01. And spec port, I will attach 1111211. These are default port, and this is Wipro MC port. And we have TCP, and app name is Wipro MC and cluster IP. Let me save this. Then we have memcache deployment now. So we'll create the memcache deployment. Memcache dep.yaml. So here I'll copy this code, that wipro db. Then we'll put it in memcache dip, and let's scroll up. And so deployment, and name is wipro mc. That's what we have mentioned here. You see that mc service, this is service basically. Here we have mentioned the same wipro cache 01. And so this is, the name is wipro mc, and the service name is wipro cache 01. And the selector, the app will be selected from the wipro mc1, and that's what is wipro mc. Then we have app is wipro mc again. Then app labels wipro mc. Then we have one more label, that's also wipro mc. Then spec, that's it here, not much. So container, name of the container we gonna attach as a wipro mc only. Then image will get it from Docker Hub default one. That's memcached, memcached. Then orgs are not required. This is default. Volume mount is not required. So let's directly go for the port and ports and the port name. Okay. Let me, yeah. Orgs. Yeah. Ports, name of the port. What is that? What we have mentioned? Name of the port is Wipro MC port. That's what I'm gonna give here Wipro MC port, and the port number is 11211, and is not required. Rest all. Let me remove that. So that's it. It's clear. It's ready now. Let me save this. Then next file is RabbitMQ deployment. rmq dep.ml. So let me copy this memcache deployment definition file and paste it here. So let me scroll up first, and name I'm gonna change it to r Wipro MQ01. So I'll change it to Wipro MQ01. So then other one Wipro MQ01. Then this one Wipro MQ01. Here also Wipro MQ01. So containers, the container name we are gonna give as Wipro MQ01 again. Yeah, and image is again official image from Docker Hub. So rabbit MQ with latest tag, and port name Wipro MQ01 port. So Wipro MQ and 01, that's the port name, and then port container port is 15672. 15, that's the default one, 15672. And in addition to that, we want to add env. So environment variable. So name, first one is rabbit MQ default pass, and value from, we will directly attach the secret key ref. So secret key ref. So name is app secret, and key is rmq pass. So this is the name of the secret, and this is key, that's rmq pass. And then what we have is one more name, that's rabbit mq default user. So we have to give the default user now, rabbit mq default user. Value, it's guest. That's it. We have provided the environment variables also. Superb. So now let me save this. So now it's time to write RabbitMQ service file. RabbitMQ service file. So RabbitMQ CIP dot aml. So let me copy this from mccip and come to this and paste it here. So name of this is vipromq01 vipromq01 and port 15672. Then here Wipro MQ, just let me check Wipro, where is that deployment? MC RMQ deployment port is name Wipro MQ01 port. Yeah, Wipro, yeah, Wipro MQ01 port, correct. Then we have TCP, then here Wipro MQ01 and cluster IP, and save this. And next, after this Wipro MQ, so what else we are left with? So RabbitMQ, okay. Okay, main thing. So Tomcat, Mcache deployment is done. So then Wipro app, the main one, Wipro app deployment and Wipro app service. So let's write Wipro app deployment first. Wipro app dep.aml. So it will be a longer one. So Wipro app deploy aml. Let me scroll up and let me copy this from db Wipro db dep. Okay, that's Wipro app. This is Wipro db. Let me copy this and paste it here. Let's scroll. Yeah, step by step will come. Kind deployment, then Wipro app. The name I'm going to attach Wipro app. Then again Wipro app. Then Wipro app. Then Wipro app. So replica. So replicas, I will keep it one only. So now the action starts. So containers. Let me come to the containers. Wipro app. Name of the container is Wipro app again. And image, I'm gonna get it from my Docker Hub account. So repositories and Wipro app, and I'll go with the version 2. So see all this tag version 2. Let me copy this and paste it here. So remove this Docker commands. Yeah, that's it. And args and port mapping we will do first. So port mapping. So name of the port is Wipro app port. Wipro app port. That's what the name I have given to it. And container port is 8080. Then, so that's one. Then init container we have to start exactly below this. Init container. So init containers. So name of that is init mydb. So what I'm gonna use is image busy box. So busy box, that's also busybox official website, and latest tag it's gonna take. So command, let me get back and open the square bracket, and inside that sh and option C. So until ns look up wiprodb do echo waiting for my db. That's what. Waiting for my db and sleep to done. Okay, so that's one, and we will do one more in it. Name init memcache. This is for memcache. So memcache, that's the name we have given. And image, again busybox. Then command. Let me put the command here. Yeah. sh option C and until ns lookup wipro cache 01 cache 01 do echo waiting for my db sleep to done. And we have few more things to be edited. That's it. No environment variable specifically here. Let me remove this. Node selector is not required. That's only for db, mysql db. Let me scroll up, and volume mounts is also not there. This basically this args. So after the name and image, directly port, nothing else. So mounts are not required. So let me remove that. Let me save that. So Wipro app deployment is ready. Now it's time to create Wipro app service. So Wipro app service.yaml. So let me copy from something else, mc, whichever is fine, and Wipro app service yaml. Yeah, name is Wipro app service then ports 80, then target port. What's the name we have given? Wipro app port. Let me cross check that. Wipro app deep deployment and Wipro app port. Okay, superb. So now Wipro app port and protocol is TCP. Selector is Wipro app. Now Wipro app. Then type is load balancer. This is very important. Very important. So load balancer, from here we are going to access from, because this is our front end. I'll show you that slide one more time. Yeah, here it is. Let me make it bigger. Yep. This is that service I'm talking about. This is that load balance service. From here only we are able to access. So this one will be, so app, tomcat app is attached. Basically this is the front end of whole application, and this front end is mapped with our load balancer. And load balancer, once you access this load balancer, the front end will be exposed. Then from the front end you are able to access the back end. So now let me get into that. Let me write. Okay, that's the load balancer type service is only for our Wipro app. So with this, our activity is completed. That second step 2, here step 3, writing all the definition files in local machine and pushing them into the GitHub repository. So let me push it into the GitHub repo. So add these changes to the staging area and committing all the definition files. Let me commit it. Save changes. So get into here. So Docker Hub, sorry, GitHub, and you see that cube. Here is that. All the files have come. All the files. Okay. So we have completed all the steps. So now it's time to, so we have written all our definition files. So now it's time to create all the objects using respective definition files. So let me get into our instance, our Kops machine. So here, so I have recloned the complete repository, and now you should be able to see all the files, app.secret.ml, everything, all the files you should be able to see now. So now what I'm gonna do is I'm gonna create all the definition files at one go. Okay, so let me say kubectl apply. So I'm not saying create, because when I say create, it may say it may throw error sometimes if one or two objects are created before. So that's why I'm gonna say apply and then F. So I'll say dot. So that's it. All has been successfully created. You should see that. So now let me say kubectl get all. Oh, that's too much. Okay, total 4 pods. Okay, at to start init. Okay, let's wait for that. 2 pods are running, Wipro MC and Wipro MQ. So memcache and 2 pods are absolutely well. They're running well. And Wipro app had to be started. It's init 0/2. And Wipro DB is yet to start. It's pending. Then coming to the services, we have 5 services. Kubernetes, the first one is default. So we have 4 services: Wipro MQ01 and DB, Wipro DB and cache, memcache, RabbitMQ and database. Out of which Wipro app, the main one, front end Tomcat app, was basically exposed, used load balancer type, remaining all are cluster type. So load balancer type, and it's still pending. Let me get into that AWS and check what's the status there. So EC2, click on load balancer, open link in new tab, and here, yes, our load balancer is started just now. You see that time? Just now. So let me click on and we'll check up the health. We'll do the health checkup. Okay, rest all fine. Status 0 of 0 instances in service. Go to the instances. Yep, not yet started. They are in a right zone, but they haven't started. Health checkup is going on. Unhealthy threshold is 2. So listeners 8031817. Okay, that's fine. Let's get back to the cops and we'll see. Okay, so these are about our services. And here we have deployments. We have 4 deployments: Wipro app, Wipro DB, Wipro MC, Wipro MQ01, RabbitMQ, memcache, database MySQL, and main app. So all okay, 2 are up and running, whereas 1 is up to date and it will take some time. Let's wait for that. And finally we have replica sets. Again 4 replica sets. 4 replica sets. Okay, these are ready, and Wipro app and Wipro DB are not yet ready. So with deployment definition file, we got replica set, and we got pod also. So now let's cross check and see the condition. Okay, Wipro app init, there is some issue, I guess it's not getting. So even WiproDB also not started. So I have figured out and I have solved that problem. The problem here is, let me do the cat of wipro db dep.ml. If you scroll down here, so this is where we faced an issue basically. Yeah, here this a was missing. Because of that we were unable to start the deployment of that container. Okay, and here this is what we have attached, and this is that volume we want to add. Okay, this is the volume ID. You see that volume ID here, vol 01D3CC. So everything is fine now at this moment. So basically our container at that app, vprofile app pod, it starts after db starting. So that's what, let me do cat of vprofile app dip.ml. You see that you have two side containers and one side container. Okay, let me scroll down. Yeah, you have two side container. One is init mydb and second one is init memcache. So I think memcache was able to start, but init mydb was unable to start because unless the database sets up, unless the database has been created, all changed and rerun it. So let me say kubectl get all, and here it is, all pods are up and running. You can see that wipro db is one by one, wipro mc one by one, and it's running. And even our services, wipro app services external IP is also available. That means our load balancer is also up, so no problem. So it's all up and running. So now you can see that even replica sets all are running. So let me say kubectl get svc one more time. Yeah, here you see that this I'll get into my load balancer, and here you could see that instances, it's up and running. Two instances, you see two instances. Now let me get into this, copy this, and I'm gonna paste, and I'm gonna paste here, and refresh it. Finally, here it is. After a long struggle, after a lot of troubleshooting, finally we got our application here. So with that, we are also able to deploy a multi-tier web stack application using Kubernetes. So now the final step for us is to, so we have created objects, we have validated it, and now it's time to clean up. Let me start the cleanup. Let me get into my server. So I'll say kubectl delete one by one. I will start with the services, and wipro db and wipro mq01 and wipro cache 01 and wipro app service. That's it, it's been deleted. So remaining things also will be deleted, And that's it. The cleaning also is going to be finished. And now I will put you this. So deploying multi-tier vProfile application is successful. And now it's time to clean up the resources. Let me delete the sudo I and let me delete the cluster. So error reading, so the cluster has been successfully deleted. Let me show you that. This is the complete log of that, and the cluster has been deleted. Let me get into that. Let me refresh it instances and refresh this. It's gone. Only one instance is left, that's Kops. So these are the services that we have created. A EC2 instance, it's Kops T2 medium and medium in Oregon, and we have S3 bucket, in Oregon, and IAM users and route 53 and elastic block storage, store volumes and auto scaling groups. These were automatically created. They will automatically be deleted. So now one by one these things we have to remove. So let me stop the EC2 instance first and then I'll uncheck it. So Kops instance terminated. So the instance has been terminated. So it's done. I will say it's done. Next, S3 bucket. We have to get into the S3. Yes, this one Kops is gone. Now let me show you that EC2 instances. Yes, no, nothing is running. It's terminated. Kops is terminated. You see that it's terminated. Now let me get into the S3 bucket. S3 services, that's a scalable storage in cloud. And so at this moment we have one bucket. Let me select this and delete. So vprofile, you have to type the name. Just copy from, no, that's not possible. Let me profile run delete. Okay, sorry. Vprofile charan Kops state, yeah, and delete the bucket. So successfully deleted bucket. So that's also done. Now this is also done. Now let me calm down a bit. Minuses. So now I am user. So Kops admin, that's the user we have created, and AWS access type. Okay, these are all fine. So I am user. If you want to delete, you can delete, or else you can keep it. So let me get into the IAM user from here. IAM user. Yeah, I have 3 users and 7 roles. So this is Kops ADM, Kops admin. If you want to delete, just select that and click delete and type and let me show you. So type Kops admin and click on delete. It will be deleted. Now I'll keep it. I'll see after some time I'm going to delete that. At this moment I'll keep it like that only. So this is also done. Now one more thing, the most important service, route 53 zone. So let me get into route 53, scalable DNS and domain name registrations. Okay, we have one DNS hosted zone. Let me click on that hosted zone. So now I will select that this is our hosted zone kubewipro.imlag.com. I'll select this and I will delete this hosted zone. To delete this, I have to type delete and click on delete. So that's it. Hosted zone kubewiproimlag.com was successfully deleted. So now what left? Only Elastic block store volumes. For that, I have to get into the EC2 instances, EC2 dashboard, and then on left menu, I'll find out that EBS volumes, Elastic Block Store. Yeah, where is that? Yeah, here volumes. And let me select this. This is what now we have created 3 GB and we have attached that US West 2A. Let me select it and delete volume and click on delete. That's it. It's been deleted. Now let me mark this also. And this one is also done. Okay. Now remaining things, remaining services, whatever we have used, these two auto scaling groups and VPC. These are automatically created by the Kops. Let me show you auto scaling groups. Okay, now it's gone. No auto scaling group. Now similarly, I will, okay. Even virtual private cloud, that's also gone because once your hosted network zone is gone, that's also gone. So these things you don't need to manually delete. So automatically these will be deleted because it was created by Kops. When Kops is gone and whole system is gone, that also will be gone. So automatically, okay. So with this, we have cleaned it up. We have removed everything, whatever we have attached, whatever we have used, all the services that we have created earlier, all the services we have stopped it and we have deleted it. So now you don't need to worry about billing. You can sleep well. Now it's time to look into one more tool. So we have seen the manual setup of Kubernetes cluster. We have used Docker desktop with Kubernetes extension to set up a single node cluster. Then we have used minikube and Docker to set up a single node cluster. And then we have used Kops to set up a multi-node cluster on Amazon Web Services. Then we are going to look into kubeadm, a kubeadm to set up a multi-node Kubernetes cluster and can be created on any platforms such as VMs, virtual machines, EC2 instances, or physical machines, wherever you want. So let's look into the installation. So kubeadm, so installation, basically this slide shows how to install kubeadm toolbox. So kubeadm, you can just get into the documentation of that, and let me get into the documentation and show you that. kubernetes.io kubeadm, and this is our kubeadm documentation. You see that here you will find out how to install. Let me click on installation guide. So before you begin, you should know about minimum requirements are this: a compatible Linux host and 2 GB or more of RAM per machine and 2 CPUs core and full network connectivity between all the machines which are inside the cluster. It could be a public or private network, whatever it may be fine. Then unique host name, MAC address and product UID. Certain ports are open on our machine, so swap disabled. That's one more thing. Okay, this is the prerequisites. Once you have all this information, then you can go with your further procedures. You have to check adapters and installing container runtime. We have to install it one by one. First, you check the network adapters. This is what you're going to do. Once the checking network adapter is done, saying NC and that, then we can go for installing container runtime. So, to install a container runtime, to run containers in a pod, Kubernetes uses a container runtime. By default, Kubernetes uses the container runtime interface CRI to interface with your chosen container runtime. If you don't specify a runtime, kubeadm automatically tries to detect and install container runtime by scaling through a list of known endpoints. If multiple or no container runtimes are detected, kubeadm will throw an error, will request that you specify which one you want to use. If you don't specify a runtime, kubeadm automatically tries to detect an installed container runtime by scaling through a list of known endpoints. If multiple or no container runtimes are detected, obviously that's gonna happen. It's gonna throw an error. So here you can find out some for Linux containered Unix at this location, path to the Unix domain socket, and CRIO container runtime interface and Docker engine. So all. Then let's begin installing the kubeadm, kubelet and kubectl. So to install kubeadm, the command kubelet and kubectl we will see. This is the actual process for Debian based distributions and Red Hat based distributions, and without a package manager you can use a curl directly without using a package manager. You can just copy this and use it, but let me go for Debian based. So first you update the apt-get package, then install apt transport https certification curl, then you curl the public signing key, it could be GPG key, then you add this Kubernetes apt repository, and then you install the kubelet, kubeadm, kubectl all together, and apt mark hold kubelet, kubeadm, kubectl. So update apt package index and install kubelet, kubeadm, kubectl and pin their version. So that's it. That's how we do installation of this. So begin you basically check your prerequisites, check network adapters, verify the MAC address and product UID are unique for every node, and check required ports. Then installing a container runtime interface. Then that's it, and finally you can install your kubeadm, saying installation of kubeadm using based on if it is a Debian based sudo apt-get, and update your apt package index and install needed to use the Kubernetes apt repository. Then download the Google Cloud public signing key, then add the Kubernetes apt repository, and finally update apt package index, install kubelet, kubeadm and kubectl and pin their versions. So you can say kubeadm init config kubeadm config.yaml. So to configure your C group driver, yeah, see, this is our config.yaml for the this one. Of course the files won't change much, there won't be, because fundamentally either it could be kubeadm or kubeadm or minikube or docker desktop Kubernetes extension, all are used to create a Kubernetes cluster. And fundamental actions will be taken care by the kubectl. And here to initialize that, you need to have a config.yaml, and we'll use kubeadm in it. So such a configuration file can then be passed to the kubeadm command. Then let's look into an example at deploying an application. So one by one, step by step, we will look into that. So we will begin with, in this example, we will deploy the WordPress content management system with a MySQL backend that we have done in our previous example with in Kops cluster. So that's why I'm not going to repeat this practically. I'm not going to practically demonstrate this. I just want to show what all steps are involved in this and what all files we have to create. That's it, nothing much, so that you can understand the difference between the kubeadm and the Kops. So yeah, only difference is cluster, how they handle the cluster. That's the main difference. Anyway, we are going to deploy that WordPress content management system with the MySQL backend. So it's a classic two-tier application where the first tier is the application server, that's a WordPress, that uses the second tier for data persistence, that is MySQL. So let's begin with our first step. It's create a Kubernetes secret. So what is a Kubernetes secret? Everybody knows. By the time you also might have known Kubernetes secret. As discussed before, Kubernetes secret allow users to pass sensitive information such as passwords, database credentials to containers. In the first step, we need to define a Kubernetes secret that contains a database name, user, and password. It should also contain the root password for MySQL. So you can see that we have created a lot of secret files also, and here API version, kind, and then metadata. Name of this is app secret, and type it's opaque, and data here are that. So this is key value pair. Key is the data name, and then value is the encrypted or encoded password. So these are all encoded passwords. So before creating a secret, we need to encode such information in base 64 format, saying echo, and mention the string that you want to encode it, and then pipe it with base 64. We have done it. So once that is done, now that we need to provide a database root password to allow WordPress to create the required database to encode the values of base 64 format. We can use the standard Kubernetes standard base 64 utility that's available in almost all Linux distributions. So base 64 format encoding, for that we'll say yeah, this is how we do. We have done it. We have taken a lot of examples. However, see, the password app db is one password, app user is another password, app pass is another password, app root pass is another password, and all were encoded to base 64 using this commands echo option n, and then mention that in strings, and pipe it with base 64, and that password which is mentioned as a string will be encoded or encoded. Okay, so now let's define. So our secret file for all are done. App db, app user, app pass, app root pass, all are done. So secret definition file has been written. So now to define a Kubernetes secret, we have to create a new file. Okay, that's done. And then what we have to do is, now we can create our Kubernetes secret using its definition in the app secret.yaml. We'll say just kubectl create f and then file name, or else you would say kubectl create or kubectl apply option f app secret.yaml. So basically, the only difference that that takes place between The kubectl and kubeadm is the way you set up the cluster. That's it. Setting up the cluster is different. Installation of kubectl and kubeadm and Kops is different. Other than that, rest all same. The remaining deployment and application, the number of files, everything is same, because you just want to create a production ready cluster. So that's it. If you are able to create a production ready cluster, that means all work will be done by the external users who will just push the code into that, and it will automatically should spin. That's what the production ready cluster, and that we'll be doing. We have done it using Kops, and now we'll be doing with kubeadm, but the process remain same. So we have created that, and now let's verify the secret creation. To verify that whether secret object has been created or not, we'll say kubectl and then get secrets, and you see that our app secrets, the secret object has been created. So the first step, creating a Kubernetes secret, is successful. Next we will move on to the second step. So here we are going to create a persistent volume. We're going to create a persistent volume. So we will create a Kubernetes persistent volume to provide the underlying storage for our MySQL database. So to define a new persistent volume, we have to create a file called app.pv.aml. Basically, this is a persistent volume definition file. So app pv.aml, so you have to mention the kind as a persistent volume type object, because we have discussed there are so many objects, out of which persistent volume is one type of object. So we can create that also. So name of this persistent volume is app-pv, and labels volume mysql. This is specifically a persistent volume, that too it's for mysql, so that's the reason. Then we have a spec. So storage 1 GB, access nodes, read, write once. So we need to have all the permissions to that. And then host path is /data/db. So in this file, we use a host path volume, which will just pass a directory from the host path into a container consumption. To specify that to specify that the persistent volume will be used for our application, we added a label called volume and then colon mysql, so that can be used to used later in a selector. So now before creating the actual persistent volume, verify that directory or data or app exists. So let me do that. So for that I'm going to say sudo make dir /data/app. So now we'll create our persistent volume. So we'll say kubectl create option f, and the file name is app option pv.aml. Then we have to verify that the persistent volume is available. Let me say kubectl get pv. That's it. Or else you can say kubectl. We can describe that persistent volume also, saying kubectl describe and then persistent volume pv / persistent volume name. What is that? It's app-v. That's it. So the second step has also been successful, and the third step is to claim this persistent volume. So to define for MySQL, we need to claim our previously created persistent volume. So create a new file saying app pvc, that's a persistent volume claim.aml, and this file consists of this information. App name of that would be whatever they want, app pvc. Access mode is 191. Read write that we're gonna look into, and after that what we're gonna see is to create the persistent volume claim using its definition. We will say kubectl create option f app pvc.aml. So once that is done, our persistent volume will be created. Now let's move on to the fourth step, that is deploy MySQL. That's where an actual deployment application has been built. So far, a persistent volume claim, and then secrets objects has been created. Now the main hero comes into the picture, that is deployment object. It's very powerful, very powerful. So now we'll create a new deployment for MySQL using the existing Docker image. Let's create a new file saying MySQL deployment.yaml, and then this file consists of a huge amount of information. So name of this deployment is MySQL deployment replicas. This is a replica set. We want one replica set, one pod of replica set, and templates. App name is MySQL, and inside that image, okay, this is MySQL, so I'm using MySQL 5.6 image, and then container port is 3306, and volume mounts is, this is the mount path where lab MySQL inside the container, and that should be, and that, and this volume mount name is MySQL pod. So then environment variable, I have to give the MySQL root password, unless, or else the database will not be initialized. If database is not initialized, then what's the point? If there is no database, how can your data be stored? So that's the reason environment variable you have to provide. And what's the password you want to take? You take that value from secret key ref. Yeah, here is that secret key ref. So name and app secret and db root pass. So then to create this deployment using its definition, okay, and few more things to be continued, that environment variables only. So one more thing is MySQL user. That's also we're going to get from app secret, and key is db user. The name of the key is db user, and the secret object name is app secret. Okay, if you want, I will show it again, but I hope you are following well. Okay, let me show that. Yeah, I think this is, yeah, you see that this is persistent volume still, persistent volume, and here you see how many app db, app user, app pass. So the name of the object is app secret, but in that object we have four keys: db name, db user, db pass, db root pass. So db pass I want this one, and then db user I want, and db name. So basically we should get this. So these are the keys: db name, db user, db pass. So you just copy this, and we will get into our deployment file. So there we're gonna mention these things. So you see that first key is db root pass, and second key is db user, and third key is db pass, and fourth key is db name, and fifth key is they have created on their own. That's a volume pvc. That's the persistent volume claim. Now let's create the deployment object using its definition file. So kubectl apply option F for MySQL deployment.yaml. Then let's verify the created wealth. Okay, let's verify that everything was created successfully. So now let me say kubectl and then get PV, that's persistent volume, PVC persistent volume claim, and kubectl get deployments to look to see the deployments. That's it. The deployment has been created and a respective object also successfully created. Now it's time to move on to next object, that is deploying, creating a service for MySQL. So as we know, pods are ephemeral. They come and go with each newly created pod receiving a new or receiving a new and different IP address. To connect a database, to connect to a database, the WordPress application should know its IP address. So if the database container is ephemeral, then how should our application keep track of the databases or the IP? So to need a service of for MySQL, create a new file called MySQL option service.yaml, and this consists of the following information. Its name is MySQL service, and port mapping is 3306, and then target port is 3306, and TCP selector is app is MySQL app. So it's service is this service is connected with the MySQL app deployment object. Then after the creation of actual service, then we will verify that service is created and corrected maply or not. You can see that. So kubectl get pods, we have only one pod mysql, but however you could see that endpoint, that means the service has been correctly mapped. So then from that output above, we can verify that service was correctly mapped to the pod for our mysql deployment in that endpoint to access our to address for the MySQL pod. Then we have to deploy the application. So all done. Remaining objects were created properly. Now it's time to deploying an application. So deploy a WordPress. So to define a deployment for WordPress, let's create a new file saying WordPress deployment.ml, and this is gonna consist of information about kind. That's what kind of definition file this deployment file, and then metadata. Inside the metadata, the name of this deployment we're going to give as a WordPress deployment, and replica set I'll go with 2, and strategy rolling update, and remaining information by and large remains same because we have done it same example in Kops cluster. So once the only difference is creating a cluster, rest all remains same, but I just want to I just want to take you through this exciting journey so that you will never forget that. So once the deployment file has been created, now you have to attach the environment variables, all the environment variables. So name WordPress DB host. So you just give the value directly, and WordPress DB user, that you can basically refer from our secret key ref. And then we have WordPress DB password. That's also secret key ref. And WordPress DB name. That's all. Okay, that one is also from their DB name, specifically DB name. Okay, so now let's create the actual deployment. Execute the command saying kubectl apply option f WordPress option deployment.ml, and then the deployment WordPress deployment object was created. Then let's verify the deployment. Let me say kubectl get deployments. That's it. It will list out all the deployment objects which are present inside that cluster. Then get a list of created pods. It will fetch a list of created pods. Then the next activity for us is WordPress deployment is done. Now it's time for us to deploy. After the WordPress deploy, so deploy WordPress. Make note of the name of one of the WordPress pods from the output above. So execute an interactive shell within the pod. Okay. So kubectl exec and option it, that is interactive terminal, and then deployment WordPress deployment and bin bash. So with that we will enter inside the pod and inside the container. So now let's check that MySQL service can be resolved within the pod using service name or not. So okay, it's so now we have to say MySQL service, and then after that this above output verifies the MySQL service can be resolved through DNS to the cluster IP address that was assigned to the MySQL service. So now let's verify that WordPress is properly configured. So let us cross check wp WordPress config.f. So db name we have to give user password and db host. You can either give it from here, or you can also give it you can configure it after creating or after opening the application. Whichever way you want, you can go with that. The WordPress pod has configured itself using the environment variables injected into the container using the values from Kubernetes secret we define here. So then we have create a service for WordPress. Next, so the final step is to expose the WordPress application to external users. For this, we again need a service. In this step, we expose a port on the node running our application and forward that to port 80 of our container. So this allows us to access the application, but it it probably is not the application, and one word and it's not one would take in production. So especially Kubernetes is hosted by a service provider, so Kubernetes can integrate with load balancing services offered by the platforms such as the Google Container Engine and AWS Amazon Web Services. So if you are using either of those, that would be an approach to take for using the balancing functionality offered by these platforms. Okay, so now this is the service file that we have written. So name of this service file is WordPress service, and app label is WordPress, and node port, the spec is node port type, and then inside that it's a node port, you have to mention that's a 30,080, and selector app is WordPress. So once the file has been written, it's time to create the actual service using the definition from the wordpress.yaml file, so it execute the command. So let me show you that. So, okay, once that is done, we can say kubectl describe, and then service name we can give so that it will describe about the service. So then we have the next step. This is to test the WordPress application. So far we have written all the required definition files, and now we have to test the WordPress application. So open for that. So all deployment done, all services are done. You have to get into your Google. If it is Google, you have to get into the Google GCE. So that's Google Cloud. If it is AWS, you get into the AWS and take the uh, load balancer IP, and then paste it in the browser. You should be able to access that application. So, and port number, if you use a load balancer, the port number could be 80. If it is some other way, you can basically you can use 30,080. Okay, so I hope you follow the installation wizard to get the WordPress up. After the once WordPress application is up and running in your browser, then you follow the installation wizard to get WordPress running through the browser. So if you are able to do that, a big congratulations, you have deployed an application inside the cluster which was created by kubeadm. Also, of course, deployment of application, the definition files that we have written, the quantity, the content that we have written, everything remains same, but the cluster changes from Kops to kubeadm. And this is the kubeadm deploying an application. So here you could see all the services, all the, sorry, not services, all the objects. From secret object, you see that secret object is connected with two pods. One pod is mysql pod, and second pod is WordPress pod. It's connected with the two. And after that we have uh, volume claim objects. This is volume, persistent volume object, which is labeled as a volume MySQL, and which is connected with MySQL data, MySQL container pod. And then we have a service pods. Obviously, service pod as to, you have two service pods you can create, one for the MySQL, second one for the service selector. So basically, the point here is the MySQL service is used to connect a MySQL database with the WordPress application, whereas the service which is used with the WordPress application is used to expose this WordPress application to the external or outside network. So in production, we may want to update the WordPress deployment, increasing the number of replicas to handle the high load or the high load for the application. So we can easily do it manually, but the preferred way in Kubernetes is to auto scaling feature for the MySQL deployment. In our example, there is no simple way to increase the number of MySQL or pods, because we cannot share the same persistent volume between several MySQL resources or processes. So MySQL does not support that. Thus, to scale database and make it highly available, we can use, for example, a Galera cluster in the multi. So there are a few more things basically you can do, but for now you should be able to see this picture. So where you have all the Kubernetes objects are visible on your screen from pod and container, WordPress pod, two WordPress pods and two WordPress containers. And then these are the labels, app, WordPress, and similarly you have a volume claim and persistent volume claim, and then secrets file. So secret file is very secret and that should not be revealed, and it will be, the secret file will be used or connected by the WordPress pod and then WordPress container and then MySQL container inside that. So with that, we have seen the Kubernetes. We have seen the creation of Kubernetes cluster using the kubeadm, and after that we have taken the similar example WordPress MySQL, a two-tier application to deploy in that cluster, in that kubeadm cluster. So Kubernetes is an open source project and it will supported by the community. So if you get any doubt, you can basically put that doubt in their official website. You can address that and uh, you can ask the doubt, any queries in Kubernetes official website. They have a very good community and they respond, they get back to us within very less time. So that's a good thing. So that's what all about Kubernetes. And so far we have seen uh, what is Kubernetes, and then what is pod, what is single container pod, a multi-container pod. If it is multi-container pod, how many containers we can have, what type of containers we can have. And after that we have jumped into the action, and there we started working on our clusters. So two single node clusters with Docker desktop and then Kubernetes extension, and then another single node cluster using minikube, and then we have deployed a we have created a cluster using Kops, and inside that Kops cluster we have deployed stateless application and stateful application, stateless application of guestbook and stateful application of WordPress with MySQL database. So that's what almost we have used minikube, kubeadm, and Kops. So we have seen enough. Now it's time to say goodbye to our most adorable and lovable Kubernetes, and time to meet on another module. And I'll see you there. Until then, keep liking me, keep liking my videos, keep subscribing, keep loving it, keep enjoying it, keep spreading it. Until then, see you. Bye bye. And in another session, another module, I'll meet you in another session, another module with more fun.